Mission Control Houston, 3 days, 19 hours, 35 minutes, mission elapsed time. Challenger is out of range of the Bermuda tracking station. We'll be picking up again in about 4 minutes and 45 seconds through the Dakar station. We still do not have use of the tracking data relay satellite due to ground station problems at White Sands. During that recent pass over part of the tracking stations in the continental United States, the crew reported that they were about to have breakfast. Commander Dick Truly made some observations on the tail glow. Previous crews doing photography out the back windows recorded a glow around the orbiter's vertical tail fin, and it was determined that that was due to the impact of the random oxygen molecules even up at the altitudes that the orbiter flies. There are a few oxygen molecules floating around up there, and when they strike the surface of the vehicle at the speeds that it is going, they cause a glow. Up at the higher orbits, that's not normally visible to the naked eye, and they record that on film with long exposures. But the orbiter is now at an orbit of actually less than 120 nautical miles. Normally, the spacecraft in the recent missions has been flying at about 160 nautical miles, and we reduced the orbit specifically yesterday to take advantage of the greater abundance of some oxygen molecules at this altitude for a materials test in the cargo bay. And Truly reported that the tail glow is visible even to the naked eye, quite easily visible at this altitude because of the greater abundance of the oxygen molecules there. Also heard from Dr. Bill Thornton with some questions about where some of his medical equipment is stowed on board the orbiter. We'll be picking up in about 2.5 minutes through the Dakar station, 1/4 of the way through orbit number 62 on this, the 4th or 5th flight day, that is, of Space Shuttle Flight 8. 3 days, 19 hours, 37 minutes. This is Mission Control. Mission Control Houston, standing by for acquisition through the Dakar station.
Challenger, this is Houston, with you through Dakar for 4 minutes.
Mary, loud and clear.
You too, Dick. Have a nice breakfast. Challenger, this is Houston. We're 30 seconds LOS from Dakar. We'll be handing over to Tidris.
Okay.
Challenger, this is Houston, with you through Tidris.
Roger, Houston, you're loud. You've broken up just a little bit, but we understood you.
You're loud and clear. Challenger Houston, we're 10 seconds LOS, and we'll talk to you in 4 minutes through iOS.
This is Mission Control Houston. We had a short period of time where we had contact with a spacecraft through the use of the tracking data relay satellite. We've now passed out of the range on the eastern end of the reach of that satellite, and the Challenger will be communicating to Mission Control through the Indian Ocean Station in about 2.5 minutes. 3 days, 19 hours, 55 minutes, mission elapsed time. This is Mission Control, Houston. Mission Control standing by for acquisition through Indian Ocean Station.
Challenger, this is Houston with you through Indy for 6 minutes.
Roger, Mary.
And Challenger for Dr. Bill. We've talked to Tom Moore, and there should be spare tapes, hand tapes, in MF57 Hotel. And we're still working on your other questions.
Okay, MF57 Hotel and still working on the sound level meter. Thank you.
And Challenger Houston, we see stars 43 and 37 in your table, and they're good, so you go to do your align at any time at your convenience.
Okay, Mary, thanks very much. These star trackers are really working 100%, aren't they?
Well, they seem to be looking real good.
Mary, reading the morning mail here, I see that under failures, impacts, etc., you have end effector snares out of the grooves. Did you guys see that last night when you were using the camera B to look into the end effector, or how do we know that?
I think we've been noticing that for a couple days, but we'll check on that and get an answer for you, Dale.
Okay, no hurry.
Challenger, this is Houston. We're 30 seconds LOS. We'll talk to you again through Yargity at 2014.
Roger, and the alignment's in work.
Copy that, Richard.
Mission Control, Houston, 3 days, 20 hours, 6 minutes mission elapsed time. Challenger is out of range of the tracking stations at the Indian Ocean Station, and we'll be picking up again in about 7 minutes over Yargity in Western Australia. Crew is beginning to get into their business activities this morning, having had breakfast. Mission Control, Capcom Mary Cleve passed up word to the crew that they have 2 stars available to allow their star trackers to work with, part of the navigation system on the orbiter. These star trackers are essentially optical devices that lock onto stars. They try to pick 2 stars, ideally about 90 degrees apart, and those are used for determining the attitude of the orbiter, measuring the angles between those 2 stars. And then that information is used for the inertial measurement units, which also help determine orbiter position. Ground also passed up word to Dr. Bill Thornton on where they believe some of his medical equipment is stowed away. There are quite a number of stowage lockers on the orbiter in the middeck area. Quite a lot of equipment stowed in those, and everything from clothing to food to supplies, flight data file books, experimental equipment. And it's very easy to see how it would be difficult to find some things if you didn't know exactly where to look for it. We're still about 5 minutes from picking up communication again through Yargity. 3 days, 20 hours, 9 minutes. Mission elapsed time. This is Mission Control, Houston.
Challenger, this is Houston with you through Yargity for 7 minutes.
We're still here, Mary.
That's good to hear, Dale. Challenger, this is Houston. Dr. Bill, sorry to say the sound pressure meter is not on board that you queried about earlier, and I would like to verify that that sound pressure and noise meter was just 1 meter you were questioning.
That's right. That's what he meant to say, Mary. Thanks for checking.
Okay, thanks. Challenger, this is Houston. We're 30 seconds LOS. We're going to lose you here for 2 minutes as we hand over to Aurora.
Roger, Houston.
Mission Control, Houston. 3 days, 20 hours, 22 minutes mission elapsed time. Challenger in the gap between Yargady and Auroral on orbit number 62. During conversation with the crew there, the Capcom Mary Cleve relayed the message that particular piece of equipment that Dr. Bill Thornton was looking for had not been placed on board. Sometime before the flight, someone remarked that given that the second tracking data relay satellite that was originally part of the cargo for this flight was deleted, and its 47,000 pound weight no longer on board, that would make room for 47,000 pounds of Dr. Bill Thornton's medical equipment. Apparently he has quite a bit on board, but this one piece didn't make it. We're standing by for acquisition through Auroral in about 25 seconds. This is Mission Control.
Challenger, Houston with you through Auroral for a minute.
Roger, loud and clear, Mary.
You too, Dan. Challenger, this is Houston. We're 30 seconds LOS. We'll speak to you again through TDRS at 20 plus 38, if not, through Mila at 20 plus 58.
Okay, we'll be looking for you at one of those places.
This is Mission Control. Challenger out of range of the Auroral station. We may pick up communication again in about 13 minutes through the tracking data relay satellite if all the ground station operations are working properly. If not, it'll be about 33 minutes before we reacquire communication over the continental United States, the Mila station. 3 days, 20 hours, 25 minutes. This is Mission Control, Houston.
Challenger, this is Houston with you through TDRS.
Roger, Houston, read you loud and clear.
You're loud and clear too.
This is Mission Control. We are getting data through the tracking data relay satellite.
Challenger, this is Houston for Dale. The RMU has a little note for you. He says that you still have 2 snares out of the groove on the RMS, and it has not changed since Flight Day 2. They were able to take a good look at it yesterday through Camera Bravo.
Also, Mary, we ended up cleaning the WCS this morning, and the vacuum vent is open.
Okay, thanks. We copy that.
Houston, Challenger, comm check from the middeck.
Read you loud and clear, Dale. How me?
Okay, have you the same. Thank you.
Challenger, this is Houston. We're sending an update on their state vector.
Okay, Challenger copies.
Mission Control, Houston. 3 days, 20 hours, 56 minutes mission elapsed time. We're still getting data and voice through the tracking data relay satellite, and we are about to pass over the ground stations through the continental United States very shortly. although we'll continue to maintain the link with the TDRS. The commander and pilot very shortly will be engaged in a test of the Star Tracker, referred to as the Star Tracker acquisition test. As we mentioned earlier, these two pieces of equipment, two Star Trackers in the forward area of the orbiter, that are electro-optical devices that are used to lock on to star pairs for navigation purposes. It helps the orbiter avionics know where the vehicle is, in combination with the inertial measurement units that are also part of the navigation system. Following that test, shortly thereafter, will be the Star Tracker Horizon Limit test. That test is designed to demonstrate the ability of the Star Tracker to track a star closer than 20 degrees to a sunlit Earth horizon. Crew is fairly quiet this morning, just going about their duties. Dr. Bill Thornton already busily working with his medical objectives, his research into the data about how astronauts in space are affected by weightlessness, something commonly referred to as space motion sickness, but really a broad range of things that can happen to an individual we call space adaptation syndrome. The agency is diligently engaged in research now to overcome the problems of the space adaptation syndrome, which can affect crew performance on short-term flights. Challenger on orbit number 63 at the present time. At 3 days and 20 hours and 59 minutes into the flight of STS-8, this is Mission Control, Houston.
Houston, Challenger.
Challenger Houston, go ahead.
Mary, it's MS3 again. Could you pass some more messages along for me?
Sure will.
Well, Dr. Young, that the contact lens then went in without difficulty, that has made repeated applications of it and has tried every application of sterile water that we can think of, but that we cannot make it stick. We cannot make it stick. I feel the pressure of the lens when the water is applied, but it simply won't stick. And if he has any suggestions, we're open. I've worked with it now for almost 2 hours.
Sounds like you're giving it a good try, and we'll try to get a hold of him and get some answers for you.
Thank you much. And Mary, MS3 again, you might point out that we have tried all the various applications of water from a drop at the time to fill in the entire orbit.
Okay, Dr. Bill, we copy that, and we'll pass it along.
Thank you again.
Mission Control, Houston, 3 days, 21 hours, 19 minutes, mission elapsed time. We're still getting data through the tracking data relay satellite and have our voice communications through that system as well. Challenger on orbit number 63, out over the western edge of Africa at the present time. A few minutes ago, we had a report from Dr. Bill Thornton asking to relay a message to one of the research physicians here on the ground with reference to a contact lens he was having difficulty with. The lens is not a prescription type lens for Dr. Thornton, but it is a specially designed lens with markings on it, which is to be used in a space lab experiment coming up on STS-9. And that lens will help in recording eye movements, that is the rotation of the eye within the socket, part of the space lab experiments coming up late October, early November. And Dr. Thornton is assisting in checking out of that lens. He reported he'd having difficulty getting it in place. The crew members still busily engaged in their timeline activities, mostly getting set up for the day's business. The pilot and the commander, Pilot Dan Brandenstein, Commander Richard Truly, will shortly be engaged in the Star Tracker acquisition test, followed by a Star Tracker horizon limit check.
Challenger, this is Houston, with some talk about the WCS.
This is Mission Control. We've lost our lock communications link to the tracking data relay satellite just a few moments ago, so we don't have our connection to the orbiter at this time. We may or may not get that back before we have loss of signal in about 7.5 minutes as we get out of the range of the tracking data relay satellite. We would then pick up again over Indian Ocean Station in about 12 minutes from now. This is Mission Control. Mission Control, 3 days, 21 hours, 23 minutes. And we have reacquired through the tracking data relay satellite again.
Challenger, this is Houston, with some discussion about your cycling the gate valve again.
Roger, here's Dale again.
Yeah, the cabin
Go ahead,
is...
Mary.
Okay, Dale, the cabin is still losing pressure at a rate of about 2 to 3 pounds per hour. And the IFM you performed this morning didn't seem to help, but cycling the gate valve yesterday did, so we'd like you to go ahead and cycle that gate valve again.
Okay, we'll do it right now.
Thanks.
Houston, Challenger.
Go ahead, Dan. This is Houston.
Packer didn't print the Omicron through.
This is Mission Control. We're having intermittent lock on the TDRS. Communication comes and goes as the antennas periodically are not aligned.
Challenger, this is Houston. Dan, can you say again, we lost everything except Omicron. We lost lock on the TDRS.
Okay, Houston, we're setting up to do this auto maneuver to the -Z Star Trek test attitude per message 36 Bravo. And the Omicron didn't print real clear. It looks like +2 to us, but we just want to verify that that's Omicron of +2 on line 12.
Okay, we'll look that up.
Okay, and Dale cycled the gate valve on the WCS.
Roger, Dan, and ECOM says that it looks like that helped the situation a lot and your leak rate seems to be declining.
Okay, Mary, thanks.
And Dan, this is Houston. That is verified a +2 Omicron.
Okay, Mary, we've got the Star Trek maneuver loaded at GNC. Would like to check it.
And Challenger, this is Houston. Your data looks good to us.
Okay.
Challenger, this is Houston. We're 30 seconds LOS. We'll lose you through TDRS and pick you up through Indy at 21:34, about 4 minutes from now.
Okay, see you there.
Mission Control, Houston. We're out of the range of the tracking data relay satellite. We'll be picking up over Indian Ocean Station in just about a minute. Some discussion on that last pass with the crew about cycling a valve on the waste containment system, the orbiter potty. There is a valve there that vents that facility to space. Has a small leak in it, characterized by the flight control personnel as just a nuisance. It's the kind of thing that has been seen on earlier orbiter flights and is believed to be a contaminated O-ring on that valve. There is absolutely no mission impact to it, and it is something that could be entirely isolated by closing another valve, but they have elected to go ahead and leave it open. It prevents any odors from the WCS area finding their way back into the cabin, and it's such a minor leak that they just elected to go ahead and leave it leaking and add a couple of pounds, a small amount of extra nitrogen or oxygen to the cabin before sleep time in the evenings. Be picking up over Indian Ocean Station momentarily. This is Mission Control, Houston.
Challenger, this is Houston, with you through Indy for 2 minutes.
Houston, loud and clear, Howard.
You're loud and clear too, Richard.
The maneuver just started to the Star Trek test attitude.
Roger, we see that.
And Mary, while we're waiting for this maneuver to complete, we can copy the information you have on the chemical that you said you routed up with.
Okay, Dan, we'll get Jeff on the line and let him talk to you about it. And Dan, we're 30 seconds LOS, so we'll probably hold up on that discussion until we get to Yargity at 21:48, if that's okay.
Okay, well, we'll probably be in the midst of that Star Tracker test, so we'll let you know when we got the time, and we'll catch you a little bit. We got till tonight anyhow.
Okay, sounds good to us. See you at Yargity, 21:48.
Mission Control, Houston, 3 days, 21 hours, 37 minutes, mission elapsed time. Challenger passing out of range of the Indian Ocean Station. And we'll be picking up again over Yargity in about a little less than 11 minutes. This is Mission Control.
Challenger, this is Houston with you through Yargity for 7 minutes.
Roger, Houston, loud and clear. And let me ask you a question about this, the Star Tracker test.
Go ahead, we're listening.
Houston, Challenger, how do you read?
Challenger, this is Houston, read you loud and clear, and we're ready to copy.
Houston, Challenger, how do you read?
Challenger, this is Houston. We read you loud with the background. How me?
Houston, Challenger, how do you read?
Challenger, this is Houston. Read you loud and clear. How me?
Roger, loud and clear, and I've got a question for you on the Star Tracker test.
Roger, Richard, go ahead. We're ready to copy.
Okay, we're in attitude. I'll tell you a little bit about that in a second. We've gotten 2 stars so far. When the asterisk appears under star presence, I did the item 8 execute. However, the asterisk did not disappear immediately, and I expected that it would. However, the second star, I did the item 8 execute and just went ahead and sat there, and after a few seconds it did disappear, but it did not disappear when I did the item 8, over.
Roger, we copy that. We'll get back to you.
Star as the star rises, it's acquired by the Z tracker, and whether I do the item 8 or not, it rises through the angular cone of the tracker and then goes away as it disappears. But I don't know. At any rate, we've so far got 2 stars.
Okay, Richard, we copy.
And another piece of information for GNC, we started the time, the maneuver per the message, not the cap, at a time of 35 minutes after the hour, and it was showing us arriving in this attitude a little bit late. So I jacked up the maneuver rate in the A1 DAP to 0.3 degrees per second to complete the maneuver, and Dan and I got the attitude about 1 minute late, and we've now readjusted the maneuver rate back in DAP A1 to the nominal of 0.2.
Roger. Richard, we copy and concur.
Okay.
Challenger, this is Houston, and Dick, we got a question for you on that. Did those star IDs appear in the table?
Negative, they did not. I got a star presence, asterisk, but no track ID, and the stars are not in the table.
We copy, thanks.
Let me make sure I read the message right. As soon as I got the asterisk, I did the break track.
That's correct, Richard.
Okay. This attitude is essentially identical to the EOIM attitude, and I'm getting to look straight down at Australia.
Now, Richard, if you see that circular drainage area that you were talking about over Australia again, there's no known impact crater in that area, and they sure would like a photo of it. And we're going LOS in 15 seconds, and we'll talk to you through Hawaii at 22:15. If we don't pick you up on TDRS before then at 22:14.
In your message, it makes more sense that it might be a dome rather than a crater, but I certainly don't know. And we have our 3rd star now, and I've already done the item 8 execute, and the asterisk has not gone away yet.
Roger, we copy that.
Mission Control Houston, 3 days, 21 hours, 55 minutes mission elapsed time. Challenger out of range of the Argody station, and at the present time directly over the central portion of Australia. We won't be hearing from the spacecraft again for about another 18 minutes until we pick up with a tracking data relay satellite if we get it on orbit number 64. Shortly thereafter, we acquire over the Hawaii station if we should happen to miss tracking data relay satellite lockup. Commander Dick Truly on that last pass discussing his activities with the Star Tracker testing that is underway. This is Mission Control Houston.
Testing 1, 2, 3, 4, 5, 5, 4, 3.
You hear me?
Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. This is Houston ACR on air. Okay, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Testing on AG1. This is Houston ACR. Test out.
Challenger, this is Houston with you through TDRS.
Roger, Houston, loud and clear.
You're loud and clear too, Richard.
Okay, Mary, we now have a star in an asterisk, and this is the 6th star we've got a star presence for during the test so far, and we're timing the I did item 8 again, the star present asterisk remained, and we're timing to see how long it does remain, and it just went out.
Okay, we copy that.
And that star presence asterisk lasted 2 minutes and 14 seconds.
2 minutes and 14 seconds.
And Mary, I guess my definition of sunset is when the sun stops striking the orbiter.
That sounds good to us, Richard.
I don't know. It's kind of a slow process, but it's getting ready to happen. Just the tippy top of the tail is in the sunlight.
Okay, we copy that. And Richard, this is Houston. The GN and C guys are pretty sure that you're getting good data, even though that item 8 hold on to a bug was not expected, and they'd like you to go ahead and keep pursuing the test.
Okay. If I remember right, I'm in the back now looking aft, but the test had terminated sunset, correct?
That's affirmative, Richard.
Houston CDR, we've just had sunset, and we have the maneuver typed in for the next test.
Roger, we copy that, Richard.
Mission Control, Houston. Commander Dick Truly reporting they're continuing with their Star Tracker tests.
Hey, Houston, Sergeant.
Go ahead, Dan.
Roger, Mary. I changed the battery in the HRM, and since there weren't any scheduled today, and we got new batteries and another spare battery, I went ahead and activated it with a start time of 21 plus 19.
We copy that, Dan.
This is Mission Control. We're continuing to get data and voice through the tracking data relay satellite.
And Houston CDR, Dr. Thornton asked me to get you to tell the surgeon that we're sending OBS data, sending OBS data down at this time.
Okay, we'll pass that on.
This is Mission Control. The crew is maneuvering the spacecraft to the proper attitude for the Star Tracker Horizon Limit Test. That test is to demonstrate the ability of the Star Tracker to track a star closer than 20 degrees to the sunlit Earth horizon. That equipment, those Star Trackers, are used as part of the navigation system on board the orbiter. We're still receiving our data and voice through the tracking data relay satellite, although we're coming up over the ground stations for the continental U.S. on orbit number 64. We're also about 3 hours away from a scheduled in-orbit press conference with the crew and members of the news media. That will take place on orbit number 66. And if we have the tracking data relay satellite at that time, well, we'll be using that satellite for the press conference. If not, we'll be using the ground station passes. 3 days, 22 hours, 26 minutes mission elapsed time. This is Mission Control, Houston.
Houston CDR.
CDR, this is Houston. Go ahead.
Roger, Mary. On that, going back to the circular feature that we were discussing in central eastern Australia, we passed over it on this rev. I'm pretty sure and we were directly overhead on this past rev at a time of 21 hours, 58 minutes, and 50 seconds. And it's large enough that looking straight down at it from 120 miles, I could only see less than half of the circle, but I'm sure that the river feature that I saw is the same one that we saw yesterday from a greater distance.
Roger, we copy that. It's bigger than we had thought you were talking about earlier.
Well, I'm not sure, looking out this front window through which I tried to get a picture, but with the HUD in the way and looking straight down, I'm not sure that I did, but whatever. I think that was the location at any rate.
Okay, thanks, Richard. We copy that.
Well, Houston. We're right above you.
Hello, Challenger. We're waving.
You bet. You got a thunderstorm out around Dayzetta somewhere, but the city looks clear. We can see all the freeways.
Would you like to give us a midnight traffic report?
Things are looking slow on the Gulf Freeway tonight.
Roger that.
Mission Control, Houston, 3 days, 22 hours.
Houston Challenger, looks like we're going right over the Cape now. A nice clear night for landing down there, too.
Thanks, Dana, and we'll check with our weatherman.
Don't believe me, huh?
He might be hiding right now.
Mission Control, Challenger's ground track, taking it right across the upper edge of the Gulf of Mexico. Over the last several minutes, craft passed directly over Houston, and just a moment ago passed over the launch site, Kennedy Space Center. Dan Brandenstein reporting everything looked clear down there. Challenger is flying at a lower than usual altitude of 120 nautical miles. Recent missions, the spacecraft is operated at about 160 nautical miles, and the special lower altitude is to facilitate an experiment on board, the interaction of atomic oxygen with materials that are carried in the cargo bay. They fly at a low altitude where there are more oxygen molecules, and with the payload bay doors open and facing into the flight path so as to ram the available oxygen molecules into the cargo bay, allow that experiment to take place. The crew is still proceeding with their star tracker tests. We have been locked up on the tracking data relay satellite for the last 15 minutes or so, and have good contact for the S-band and the KU-band systems. We're at 3 days, 22 hours, and 37 minutes into the flight of STS-8. This is Mission Control, Houston.
Houston Challenger.
Challenger, this is Houston, and we're having a good time watching your TV right now. It's pretty amazing.
Yeah, that's what I was going to ask you to do, is I just turned on camera alpha so we could put it on the VTR, which we are doing, but if you're getting it real time, we'll just leave it on for a while.
Thanks. It's a real great light show there.
Houston CDR, that bright spot just to the right of the tail is a star or planet.
Roger, we can see that real well.
Hey, Mary, if you could check with the camera people, just a straight still 70 millimeter or 35 millimeter, and come up with a setting that might be able to capture this, I'd like to hear it.
Okay, we copy that, Dan, and we'll get back to you with it.
That planet is now just rising just above the air glow.
Roger that, and we can see the air glow.
Hey, Houston Challenger, we have a mid-deck camera set up also that if you want to look at Dr. Thornton and the two MSs are down there doing some of their work.
Roger, Dan, right now we're having fun with a prop corresponding your vernier jet firings with a good light show.
You bet. I don't know if you can see it, but we see about 3 more stars now appearing to the right, just to the right side of the picture, outboard of the port OMS pod.
Roger, we got 2 anyway.
Yeah, it's actually this well, there's hundreds out there, but I can see the two that you are seeing. You're about to get a third bright one. There it is now.
Roger that, we see it.
Mission Control, Houston. We're looking at some television coming down from the orbiter, courtesy of the TDRS KU band system. We were not planning on getting some television, but the crew had the cameras turned on. There we go. We have some tail glow.
We just saw the pitch jet.
Glow caused by the RCS firings there out the rear of the orbiter, and you can generally make out the outline of the orbital maneuvering system pods and the vertical tail fin. And just to the port side of the tail fin is what Dick truly described as probably a planet.
And regarding the best way to take pictures that was asked earlier, you're going to need ASA 400 film. If you don't have any of that loaded in, then we don't think it'll work, but you'd have to use an F2 stop with ASA 400. And that's on a 35 millimeter camera.
Okay, thanks. Yeah, well, unfortunately, we didn't have enough foresight and load allow that. The stuff we had, we used in the tail, not in the tail glow, but the heat pipe.
Okay, we copy that, Dan, and Jeff's here with your glow photography stuff. Might go well with the live TV.
Okay. You can see on the TV now that we haven't moved the picture, but the tail is essentially stopped glowing. I guess velocity vector shifted around. I'll leave it running in this. I'll leave the camera running if you like, and we'll just see what happens.
Okay, thanks. Sounds good to us.
This is Mission Control. The crew has left one of the payload bay cameras on, and it is pointing back in the direction of the tail. We're getting live video from the Challenger at this time. Challenger is in darkness, however, and you can only barely make out any of the features of the spacecraft and what Richard truly described as probably a planet in the background. A little earlier we had a faint outline around the tail, the vertical tail and the Ohms pods due to the oxygen interaction, but the orbiter's attitude has shifted slightly, and the oxygen molecules are no longer striking that surface and causing the tail glow. However, the Challenger is about 5.5 minutes.
It's completely dark now. I'm going to tilt and pan the camera up and see if I can show you around.
Okay, we'll try to catch the belt.
Challenger about 5 minutes away from daylight terminator, where they will be seeing a sunrise. And if the camera is still operating at that time, we still have TDRS KU band, we may get something at that point. Dick truly pointing the camera in a different direction at the present time.
We're all real impressed. We can see it real well. Isn't it the wrong time of the year for Orion? And Richard, this is Houston. The Mocher has a special request.
Go ahead, Houston.
I think we're about 5 minutes from a sunrise, and if you guys don't mind working the cameras, we'd like to take a look at one.
Sure, be glad to.
Thanks.
Okay, now let us try to figure out where it's going to occur and which camera, so hang on a minute.
Okay, Houston, I think we just figured it out. We're going to try and get a camera on it.
Thanks, Dan.
Mission Control.
It looks like the attitude we're in, and with Delta being dead, that's probably the best we can do, but we're going to give Charlie a try real quick.
Okay, well, we can see that.
Mission Control, crew attempting to point one camera in the direction of sunrise, and we should be getting a good picture of sunrise from 120 nautical miles up in space.
Okay, Houston, there it is from Charlie.
Thanks, Dan.
And I seriously doubt that TV can do it justice.
In Houston, I've got it on black stretch. If Inco can suggest anything best, we're looking black and white, and I'm really not sure what how it's coming out on yours.
Okay, I'll check with him.
Okay, Houston, the camera itself is in the shadow of the starboard wing.
Roger, Richard.
This is Mission Control. We're getting some pictures of a sunrise from space. Camera looking out over the starboard wing of the orbiter.
And Houston, Challenger.
Go ahead, Dan. This is Houston.
Roger, on the EOIM experiment, those samples of A frizzy they had there, as we recall, they all started out being pure white, but after a night of forward into the velocity vector, some of them are still pretty white, but some of them have changed to various shades of gray, and one of them is almost, I wouldn't say it's black, but it's a quite dark gray. I tried to document it on film this morning with the 70 millimeters, so I've got some pictures of that.
We copy that.
Mission Control, Houston. 3 days, 23 hours mission elapsed time. Challenger passing over the sunlit portion of the Earth now and about to cross the western coast of Africa. We're seeing...
And Houston, if you're interested, we got camera A zoomed in on that A frizzy now.
Okay, we'll take a look, Dan.
A pretty low grazing angle. You probably won't be able to see it as well as we can in the colors, how they've changed.
Well, we can see it well enough that the payloads officer is flipping his book.
Run that past us again, Mary.
Picture's good enough that you have the payloads officer in his book looking for his pre-flight photos.
Okay, looking at them, as you look at them, the small four ones, the one furthest aft near the flag is the darkest, and then the second one from the back is one of the ones that's pretty white yet. And then the second one from the front, once again, of the small squares, is the second darkest. That's turned quite a bit. The front one also is quite white. And the two large ones are about the same color, and they're a medium gray.
Roger, Dan. We can see that from here.
This is Mission Control. We're looking at some of the samples of the material mounted in the cargo bay for the oxygen interaction test. This material is exposed to the oxygen molecules impacting them at this lower shuttle orbital altitude. The test was set up to observe the erosion effects on that material from the oxygen. And the pilot, Dan Brandenstein, noted that some of this material had changed color. The shuttle is out over southern Africa at this time, and we're just a couple minutes away from losing contact with the tracking data relay satellite. We should still have voice through the Botswana station if we switch over to that in about a minute and a half.
Houston, we're going to leave the cameras sit where they are now. We got to go back and get ready for this next test.
Okay, Dan, thanks for the show. We really appreciated it. Had a good time.
And Mary, camera Charlie has a good view of the ground on it.
Okay, thanks.
Mission Control, we've lost our connection with the tracking data relay satellite now, passing beyond its range. Still have voice capability through the Botswana station.
And Dale, this is Houston. Thanks for the offer, but we have just handed over Botswana, and we're now AOS over Botswana for another 3 minutes.
Okay, too bad. And Houston, we started the horizon limit test on time. Got a star presence in the -Z tracker, but so far no track ID, and we're in Star Track. And we just put star 52 into the table.
Roger, we copy that.
Hey, Houston CDR, the Z tracker is just continually putting star 52 into the table. It's taken about 8 to 10 seconds, and I'm continuing to clear it if that's what you'd like me to do.
Roger, Richard, we copy, and that's affirmative. We'd like you to continue to clear it.
Okay, we'll do this right up to the end of test time.
And Challenger, this is Houston. We're 30 seconds LOS, and we'll talk to you through Yargity at 23 plus 22.
Okay, and it just went into the table the 8th time.
Roger, we copy that.
Mission Control, Houston, 3 days, 23 hours, 8 minutes mission elapsed time. Challenger has passed out of range of the Botswana tracking station in southern Africa. We'll be reacquiring in about 13 minutes over Yargity in Australia. And it's about 40 minutes before we pick up the tracking data relay satellite again. Dick Truly reporting that they are continuing with their Star Tracker Horizon Limit test. During that previous pass with the tracking data relay satellite, we had some spontaneous television down from the orbiter. They were locked up with the KU band and had capability for television. The crew simply switched on some of the cameras, and we were able to take a look at what the crew was seeing as they passed into the daylight side of the Earth. We got to see a portion, at least, of a sunrise from space. There are some more KU band test activities listed in the timeline for this morning over the next hour. And then on orbit number 66, as we get within range of the tracking data relay satellite or the Hawaii station, whichever is operable at that time, we would be having the crew's in-orbit press conference. It's a little over 2 hours away. 3 days, 23 hours, 10 minutes, mission elapsed time. This is Mission Control, Houston. Mission Control standing by for acquisition through Yargity.
Challenger, this is Houston, with you through Yargity for 6 minutes.
Hi, Mary, and Richard's coming on with some data for you.
Hello, and we're standing by ready to copy.
Okay, on the Star Tracker Horizon Limit test, we ended up, if my count was right, putting the star went into the table about 15 times. It was taking generally 8 to 10 seconds from the time we cleared the table until it acquired and put it back in, until we got to about 23 hours and 10 minutes. And then it would get a star presence for a few seconds. It would get a track ID for a couple of seconds, but I guess it was just too low, and it wouldn't. It stopped taking them, and so by 23:11, the end of test time, it had not gone in the table for a little over a minute. So as far as I could tell, it looked like it should be some good data. I don't know what the conclusions would be.
Sounds good to us, Richard.
Okay, and we've got the maneuver loaded to go to the KU band test attitude.
Roger. Challenger, this is Houston. We're 30 seconds LOS. We'll talk to you again through TDRS at 23:49.
Mission elapsed time 3 days, 23 hours, 29 minutes. This is Mission Control. Challenger passing out of range of the tracking station at Yargady, Australia. On the last leg of orbit number 64, we'll have a loss of signal period of about 20 minutes before we pick up again over the range of the tracking data relay satellite out over the Pacific. That last pass, Commander Richard Truly reporting that they had completed the Star Tracker Horizon Limit Test, and the orbiter was maneuvering to the proper attitude for KU band testing. Crew appears to be a little bit ahead of the timeline at present. And we're a little bit less than 2 hours away from the start of the on-orbit press conference with the crew. This is Mission Control, Houston.
On the duplex side of it. Okay, I had something a little bit ago.
Hello, this is Hawaii Contact.
Okay, I hear you to Hawaii Contact. This is Houston ACR. How do you copy?
Okay, you're loud and clear.
And you're coming in here loud and clear, Hawaii.
Mission Control, we have acquisition through TDRS at this time.
Challenger, this is Houston with you through TDRS.
Yes, initial pitch rotation was started on time.
Richard, this is Houston. Say again. You were broken and cut out. Say again. Your last.
Roger, Mary. I said we started the KU band common track first pitch maneuver on the time.
Challenger, Houston, and Roger, Richard, we copy that your last transmission, that you started your maneuver on time.
Yep.
Challenger, this is Houston. We're 30 seconds LOS. We'll try handing over to TDRS. If we're still having cutout problems, we'll talk to you through Buckhorn at 23:57. Challenger, this is Houston with you through TDRS. And we've got a couple items to discuss with you when you're ready.
Houston, we're reading you loud and clear. Go ahead.
Okay, Dan, you're loud and clear too. We'd like you to know that the WCS leak through the gate valve is down to 1.2 pounds per hour since you cycled the gate valve. But in order to avoid an alarm doing about the same time, 1 rev from now, we'd like you to do a manual cabin repress at this time. Use an Orbit Ops checklist 5-10.
Roger, Houston, and verify you want to repress with N2.
Roger, Dan, we would like to use the procedure as written. That uses O2 and N2.
Okay.
And then the second item is giving you a little background for the press conference coming up when you're ready to talk about that.
Okay, Houston, go ahead.
On the next rev, when we come up on Hawaii, we're going to start the show. And
Break, Mary. You're coming in 2 times in about half a second out of phase.
okay, we'll try to check that.
Okay, that one was perfect.
Okay, how do you read now?
Loud and clear.
Okay, I'll try again. Over Hawaii, we're going to start the press conference, and probably there'll be 2 people speaking to you there. Then you'll have a small break as we hand over to TDRS, and it will continue throughout the rest of the coverage with everyone having a chance to talk. However, if we run into problems with the KU band coverage, then if we lose a lock, we'll pick you up AOS at Goldstone. Now, if we lose lock later than that, we will pick you up AOS Mila.
Okay, we copied all that. Sounds good.
This is Mission Control. 4 days, 0 hours, 7 minutes mission elapsed time. We have acquisition through Mila.
Challenger, this is Houston with you through Mila.
Roger.
Challenger, this is Houston. We'll be handing over to TDRS in 10 seconds.
Roger.
And Challenger, this is Houston. We're back with you through TDRS now. Challenger, this is Houston, and we can see the cabin repress is complete, and it all looks good to us now.
Say again, please, Mary.
Roger, Richard. The ECOM says your cabin press looks good now.
Okay, we had completed the procedure, and then the WCS was used shortly after that. We did trigger one more alarm, but it looks good to me, too.
Okay, we copy that. Challenger, this is Houston.
Roger, Houston. Do you see that L3D got deselected, the leak?
Roger, we see that, and we'd like you to press on and leave that deselected at this time.
Roger, I concur. Houston, CDR.
CDR, this is Houston. Go ahead.
Roger, I'm sure this is no news to prop, but on page 10-10 in the Mal book, we end up in step 31. Sorry, block 31.
Roger, we copy that.
Go ahead, Larry.
Yeah, on that L3D alarm that you got in the deselect, talking about page 10-10, block 31, after looking at that lovely or statement, Prop would like you to know that he thinks that it is a real, very small fuel leak, and the fuel injector temp is hanging right around 2021, which is the limit.
Okay, we understand. Thank you.
Houston, Challenger.
Go ahead, Challenger. Houston here.
Roger, we terminated the pitching for the KU band test at 37 minutes, and now we've set up to initiate going to the optimum KU attitude at 45.
Roger, we copy that. And Challenger Inco wants you to know that we got some good data during that test, so thanks a lot.
Good show. Sounds like the TDRS is working real well.
Roger that.
Plus, we enjoyed doing acrobatics on orbit.
Sounds like a lot of fun.
You bet. Houston, CDR.
CDR, this is Houston.
Roger, could you pass on to Bob Stevenson or Scully Power or one of the oceanographers that the Yagelhoff current has been very quiet and has very little structure in it this whole mission?
Roger, we got that and we'll pass it along.
Okay, we have seen a good bit of structure, particularly in the water east of Australia and a great deal in the Central Pacific.
Okay. And Challenger, this is Houston. We're 30 seconds LOS, and we'll talk to you again through Yargity at 0057.
Roger, see you there.
Mission Control Houston, 4 days, 0 hours, 44 minutes mission elapsed time. Challenger out of range of the Botswana tracking station, Southern Africa. Orbit number 65. During that last pass, we had some conversation with the crew over one of the reaction control system jets that was deselected. A propulsion officer in mission control was watching that during our acquisition through TDRS, noting that temperature was going down on that jet, indicating that it may have a very small leak, fuel leak. So that one was turned off, and they don't expect any impact from that. We will be having the crew press conference coming up in just a short while on orbit number 66 as we come within range of the Hawaii station and the tracking data relay satellite range. The astronaut crew on board will have their television set up, and we expect to be getting television from the spacecraft. And we also have the 6 press representatives that will be taking part in the crew conference that will be televised from room 135 in building 2. That room is not going to be open generally. It is set up with the cameras and the panel of the 6 journalists that will speak with the crew during that press conference period. So that room will be closed to general traffic. We're about 11.5 minutes away of a brief pass over the Yargity station, very low elevation. We may just barely have contact with the spacecraft at that time. And then the next reasonable pass will be over the Guam station in 22 minutes. 4 days, 0 hours, 46 minutes, mission elapsed time. This is Mission Control, Houston.
Challenger, this is Houston with you through Yargity for 3 minutes.
Roger, Mary, reading you loud and clear.
You're loud and clear too, Dan. Challenger, this is Houston. We're 30 seconds LOS. Talk to you again through Guam at 1+08.
See you there, Mary.
Mission Control, Challenger out of range of the Yargity station. About 7 minutes away, 7.5 minutes away from the Guam tracking station. And we're about 20 minutes, a little bit around 20 minutes away from the start of the crew in-flight press conference. Just a reminder, the participants in that press conference, the 6 news media representatives, will be in room 135 of building 2. And only those representatives, along with the television equipment and cameras, will be permitted in that room for the press conference. The room itself will be closed to general traffic for this event.
Challenger, this is Houston with you through Guam for 5 minutes.
Roger, Houston, loud and clear. And I'd like to give me a second. I'm going to set up the conference communications configuration on board and give you a call.
Okay, Richard, we're standing by.
Okay, Mary, comm check from the middeck.
Roger, Dale, you're loud and clear. How me?
Okay, have you the same. Thanks a lot.
Challenger, this is Houston. We're 30 seconds LOS. We'll talk to you through Hawaii at 1+21.
Roger, Houston, loud and clear. We'll see you there.
Mission Control Houston, 4 days, 1 hour, 13 minutes mission elapsed time. Challenger passing out of range of the Guam station. We'll be picking up over Hawaii in about 7.5 minutes or so for the start of the crew in-flight press conference. This is Mission Control, Houston. This is Mission Control, Houston. 4 days, 1 hour, 20 minutes mission elapsed time. Challenger coming up on the Hawaii station in about 45 seconds for the start of our crew in-flight press conference. This is Mission Control.
Challenger, this is Houston, with you through Hawaii for 6 minutes with PAO standing by.
Roger, Houston, read you loud and clear. Have me.
You're loud and clear too, Richard.
Captain Truly, this is Al Rossiter of United Press International. You've completed about 2/3 of your flight now. What is your assessment of the mission's accomplishments so far?
Al, so far I would say that the flight has been extremely successful. We've had a great time watching the fireworks on the night launch, the seafless operation and the inset deploy, and the words we've heard from Mission Control on the inset are that it's working very well. The TDRS testing has gone well. I'm very happy about it. How does it look down there?
It looks great so far. Colonel Bluford, President Reagan on Wednesday congratulated you for paving the way for other blacks in space. You didn't have a chance to respond then. What would you like to say about your flight? What is its significance as far as blacks are concerned?
Well, I didn't remember. The flight, I think, is just going to be one of many flights in which black Americans are going to be flying in space. We have 2 black Americans that will be flying next year, and there'll be many more black Americans flying in the future.
Dr. Thornton, have there been any crewmen who have had symptoms of space sickness, and if so, could you tell me how many and to what extent?
There have been, in a crew this size, the usual range of symptoms that occurred during adaptation.
Dr. Thornton, could you repeat that?
As far as going into exact details, if you consulted me in your office, why, I think this would be enough said.
I'm sorry, I think we lost part of your answer, the initial part. Could you repeat that, please, sir?
Yes, I say that we have seen a variety, a range of symptoms of adaptation, and that's fortunately what I came to study. And as far as going into exact details, I still consider myself a clinician.
Commander Truly, this is Howard Benedict of the Associated Press. On Tuesday, you lifted off on the first night launch in the shuttle program, and that was a spectacular sight. Now, on Monday morning, you were to make the first night landing. Does that give you any concern?
Howard, Dan and I have trained and tested and taken a look at the night landings and the night lighting systems for almost a year, and with the weather predictions that we've seen from Edwards, no, we're not concerned. We're looking forward to the landing, but I just soon postpone it 2 or 3 days and stay up here.
Dr. Thornton, has your research up there uncovered any clues about what causes motion sickness?
I would say that I learned more in the first hour and a half on orbit here than I had by all of the literature research that I'd done and all the active work in the past year. I would say yes.
Okay, for Guy Bluford, in one of the papers today, there was an editorial cartoon showing a young black boy with a vision of you, Guy Bluford, floating in space, and they borrowed the caption from Martin Luther King. It said, "I have a dream." What message do you, as the first American black in space, have for black youths who might aspire to become astronauts?
I think just to show that that possibility does exist and that dream can be fulfilled, and that there are many opportunities for other blacks to fly in space as well as mine.
Now I have one for Dale Gardner. For 2 days now, you have been testing the remote arm lifting a 4-ton package around the bay. Do you feel that this arm now is qualified to lift a 10-ton package on the 13th flight next year and also rescue a satellite as is planned?
Well, this 8,000-pound payload was an easy step up from the 3,000 pounds that we had in STS-7. The guys on the ground went off to take this data and put it in the computers and do predictions as to how the 20,000-pound payload will handle. But if the step from this one to that one is as easy as this last step, I don't think they'll have any problems. It flew very nicely, and the Canadians ought to be very proud of that piece of gear. It really works nice.
Okay, Dick, we're about a minute and a half LOS. We're going to hand over to Tidris. We should pick you up pretty rapidly after that.
Okay, Mary, we'll see you AOS Tidris.
See you there. Challenger, this is Houston with you through Tidris with PAO standing by.
Unclear, Mary.
You're loud and clear too, Dale.
Commander Truly, this is Lynn Scher from ABC News. In view of your participation on the task force that recommended it is both possible and desirable to fly private citizens on future shuttle flights, I'm wondering, as commander of this mission, how would you have liked having a passenger on board?
Hi, Lynn. How are you doing? Yes, I did participate in that, and I do think in the future we can safely and easily fly private citizens in space. And with the proper introduction and preparation, I don't think on this flight we'd have had any problem with one. As a matter of fact, this probably would have been a nice one to have a passenger, a citizen, with us.
Would there have been any aspect in your estimation that a private citizen could not have handled?
No, I don't think so.
I wonder if I could direct the same question to Dr. Thornton. From what you have seen, Dr. Thornton, of the reaction of the other crew members and from your own tests, do you believe that a private citizen would have behaved any differently?
No, I see absolutely no contraindications to flying private citizens in reasonable health.
This is for Dan Brandenstein. Dan, before the launch, you described yourself as a pretty easygoing and unruffleable guy. You also said that it took a lot to get you worked up. I'm wondering if there is anything on this mission, including ascent, that has changed that image of yourself.
Putting me on the spot, No, well, I don't know. It was mighty exciting. I don't think I've ever been as excited as I was on that ascent. That was a real thrilling ride. And I think equally as thrilling was the first sunrise on orbit. It was just a fantastic view that is pretty hard to describe.
This is for Dale Gardner. Dale, I'm wondering, from your perspective now at some 138 miles above us and earlier much higher, does it change your outlook on life? What is it that you are thinking as you are floating above us at that orbit?
About the next meal. No, but really, the view of the Earth is fantastic. Up to this point, of course, I've seen all the continents mostly on maps, and it's really quite a sight to go flying over them at 300 miles a minute and to see all those sights that have previously been on paper before your eyes. It's a beautiful world down there, not only the land but the oceans, and I don't think I'll ever forget it for the rest of my life.
This is for Guy Bluford. Colonel Bluford, before you went up, you talked about the fact that you realized you would be a pace setter, but you didn't think you had to be perfect. It seems to us that your launch of the satellite was indeed perfect. I wonder if you could assess your own performance so far.
Sounds like a loaded question. I've been very pleased with the way things have gone on the mission, not only with my own performance, but with the performance of the total crew. I think as a total crew, we've done a rather spectacular job.
And finally, for Commander Truly again, it looked at one point as if the PFTA might have been positioned in the figure of an 8. Could that have been possible?
No, the arm doesn't have quite enough joints for an 8.
And the PFTA didn't help you at all, huh? Commander Truly, one more. You all have talked about the routine aspects of shuttle flight. Does this press conference, as you orbit some 140 miles above us, feel routine to you?
No, I don't think this is a routine press conference. We didn't have any problem at all in doing it and talking to you. But no, I don't think it's routine, but I think it'll probably happen more and more. And I hope it allows people in America to share, with the few of us that can see the Earth, a little bit of it.
Well, Dick, so do we. This is Roy Neal of NBC News. And my first question's for Dr. Bill. Dr. Thornton, as the oldest astronaut to fly, I wonder if you could give us a little analysis on whether or not space flying really is for older folks, the way John Young would have us believe.
Well, we certainly don't stop life just because we have a few years. It amounts to the condition of the individual and that sort of thing. And as far as John and I are concerned, we're still somewhere about 30, and I would think that most of a large part of America is in the same situation. Seriously, we should not count physical condition by the number of years, but look at the physiological age and capacities of an individual.
I noticed that old man, Dale Gardner, was shaking his head affirmatively, by the way. Now, here's one again for Dr. Thornton and for Colonel Bluford, if I may, and in that order, please. Dr. Bill, after being up there, flying around inside the Challenger and looking outside at all the clouds and the cities down below, I wonder what you see other than just a picture postcard. What do you see when you see the Earth?
Frankly, I see a pretty humbling experience when you stop and think that this may be the only spot that supports life for at least 5 light years and maybe more. It is a very unique spot indeed, and I think one that deserves very careful of assessment of our responsibilities to it.
Guy?
For me, I see a beautiful world. A world that has supported us not only on the planet itself, but is also supporting us in space. And I hope that our contributions will make that world even more beautiful as years continue on.
All right, my next question is addressed to Dick Truly and to Dan Brandenstein as pilots. Here on Earth, we've been very concerned for the last couple of days about some Russian jets which shot down a Korean commercial airliner with 269 people on board. Now, as pilots, have you been too cut off there in space to follow events here? I know that this was sent up to you on your morning newspaper, your teleprompter, but have you been too cut off, or do you have some thoughts on this situation?
Well, I think the situation is absolutely ridiculous and terrible, and although I know nothing about it other than the short news summary that was sent to us last night, which incidentally, Roy, I requested, because without some news you can get cut off. I'm sure you remember back in Skylab we used to send the crews news every evening, and I think that's a good idea. We enjoyed looking at those news summaries, but that certainly was the most disheartening one of them all. Here, Dan.
Dan, how about you?
Well, I pretty much have to voice the same opinion that Richard did. I guess I can't possibly understand a single reason for shooting down a commercial airliner, regardless of where or when it is. But once again, we don't have all the facts, and you can't make a final judgment until you know all the facts.
And finally, for you, Guy, when you get back to Philadelphia, what are you going to tell all those folks?
That flying in space really is a lot of fun, and working in zero-G is really a piece of cake, and the view out there is really spectacular.
Good morning, everybody. This is Mort Dean from CBS. I wonder if any one of you would be willing to raise his hand and say, yes, I suffered from the dreaded space adaptation syndrome. Do you want me to repeat that question?
No, Roy, we'll wait and let you come experience it for yourself.
Okay,
That's
Doctor.
fine, Martin. We'll let you experience it for yourself. Then
When?
you can give a better first-hand report.
Well, that's a deal, but let me pick up on that, Dr. Thornton. I know you've addressed yourself to it before, but have you learned anything that would lead you to say that you're on your way to solving that problem?
Oh, I think certainly my colleagues would take me to task if I were to be so bold as that. But again, I would emphasize that this is the place to study the problem. And again, I would say I think I learned more than in the first hour and a half than I have in all the previous years that I put in on it. And I would certainly hope that that I will be able to add something to the solution of the problem, because I'm convinced that it is very solvable.
Commander, truly, was it a...
Add that it's a very transient thing, and it's not the dreaded thing that people might talk about sometimes.
Commander, truly having two celebrities on board, Bluford, the first American black, and Thornton, the oldest astronaut yet to fly, was it a difficult crew to handle?
Morton, you have to watch this crew every minute.
What about how habitable the spacecraft is with 5 men on board and no shower on board? How was it to live in for the 5 of you?
Frankly, I think a crew of 5 on the Space Shuttle is a good size. We've stayed out of each other's way most of the time. We've done our job, but we've also had plenty of time to fix meals and visit with each other. And of course, with 5 people, you always have at least one person that can take off and really enjoy it and work on the fun things of space flight. So I think this is about the right size. And frankly, I was thinking on that first day, after about 5 hours, all 5 of us had been working every minute, and now I look back on Flight 2 with Joe Engle, and I don't see how those 2-man flights got it all done. There's a lot to be done up here.
Let me ask this of Guy Bluford. Did you find that it was totally impersonal to be up there, or is there a place to hide and be by yourself with your own thoughts? I think we're missing the best part of this.
I think there's a place to sort of hide and be by yourself. You can go up against the window and watch the world go by, so to speak, and reflect on how lucky you are to be here and how beautiful the view is. So there are times in the flight where you can reflect on the experience that you're having.
And Dan, rather quickly, what will you remember most about this trip?
Well, it'd be awful hard to forget that launch.
Okay. Thank you very much.
Dr. Thornton, this is Gary Schweitzer at Cable News Network. You said earlier that a range of symptoms of the space sickness syndrome had been seen. Without getting too graphic and without violating the confidence, which I know you don't want to do, of your patients up there, can you give us a description of that range of symptoms? What kinds of things did you see?
It can cover the space adaptation syndrome. It can cover, obviously, all the way from upset stomach to a drowsiness, malaise to just a slight giddiness.
Well, after your several days of data gathering here, you said even in the first hour and a half you had more valuable study than much of the time you spent here on Earth studying the problem. Are you at a point yet where you can even speculate about the leading cause or causes of the syndrome?
No, I think it would be very premature at this time, and I'm sure I'd be taken to my task by my colleagues for speculation at this point. On the other hand, I have absolutely no reason to think that it won't become a problem of the past, just as in the early days, the weight losses that were of great concern, which turned out to be a simple enough thing, or the problem of orthostatic hypotension when we returned are pretty much things of the past. I think this will also follow the same course.
A final question for you, Dr. Bill. Not to belabor your age anymore, but at age 54 and being the oldest in space yet, have you seen any changes in yourself in blood pressure or in any of the other things you're monitoring that you didn't see in the others, didn't hear from others in the past, or that Dr. Thagard on the last flight didn't report?
Oh, I don't believe so. Richard, did you, has anyone noticed anything? No, actually, my physiological reactions and all seem to fall pretty much within the normal range. Again, I would encourage people to count age by physiology rather than by simple chronology.
There is one last question for you, Dr. Bill, that I don't think any of us would want you to get by without answering. That is, how are the rats today?
Oh, I think, let's just say that the first day it was obviously a new experience for them, but like the rest of us, they've settled in quite nicely, feeding, grooming, and such as that, doing well.
Commander, truly, before the launch, you acknowledged that the mission may lack pizzazz in the public's perception, but you said you didn't share that view. I'm wondering now, in light of that earlier perception, what you would say to people who look at this mission that way. Perhaps what accomplishment are you most proud of?
Frankly, I think, this mission was, we did have to change our manifest on very short notice a few months before the flight. And I think it's a great credit to the maturity of the Space Shuttle program that we could meet our commitments to our customer, the Indian National Satellite, and to change the manifest to a payload that we were going to fly anyway, that we had a crew that could get trained in just a short period of time, that we could essentially fly on time. And I think the news story would, frankly, be much closer to the front pages had we not been able to do this. So I think, frankly, it's been a well-planned, even though it was a late-planned mission by necessity. And so far, it's really gone very well.
Dick Truly, this is Al Rossiter Jr. again. You're scheduled to land in the dark early Monday morning. Will the lack of daylight make this a more difficult landing than your first flight?
We've certainly approached the first night flight with a great deal of care, just as in all test flying you do. But we have developed a night lighting system that, in consonance with good weather and with the heads-up display, as far as doing it the first time, I think Dan and I are quite ready to do it, and I don't frankly think it's going to be more difficult than a day landing.
For Guy Bluford, you spent much of your first day in flight operating the electrophoresis biological processing experiment. How did the living cells appear to separate? Did the experiment seem to operate as planned?
Yes, I think the whole operation, both the first and second day, worked out very well. We had very few problems with the CFIS equipment, and as I said, we pumped out 2 samples on the first day and 4 samples on the second day, and the whole operation went very smoothly.
Dick Truly again, there appear to have been very few problems on this flight. Does this, in your view, make it the most trouble-free shuttle mission so far?
Oh, I don't know. I haven't counted them up. We certainly haven't had a lot of major problems. But I was thinking just this morning how different this was from Flight 2 with regard to the scramble that was. It was a different kind of a flight, but I'll tell you, this is the way to fly in space, where you have several people on a crew, a spacecraft that's cooperating. You can get the job done and have time to do some of those extra things that you wouldn't get to do otherwise.
For Dr. Thornton, again, could I return to space motion sickness just for a moment? Does it appear that there might be ways to prevent the development of these symptoms in the first place?
Oh, once again, I won't speculate, but I certainly have every confidence that as time goes on, hopefully from some of the results of this flight and others which will follow, that once again we will be able to ameliorate most of the unpleasant symptoms that do develop.
Commander Truly, this is Howard Benedict of AP again. It's been a very successful flight. Could you kind of assess how it has advanced the overall goals of the Space Shuttle program and some of the things you've done?
Are you referring to the shuttle program in general or this flight? I'm sorry.
No, the shuttle program in general.
Well, it was only a year and a half ago that I flew on the second flight. At that time, we were worried, frankly, if you remember those days, we were worried about the safety of the vehicle, the thermal protection system, the engines, those kinds of things. And we have graduated in a little over a year and a half to a system that's routinely, we think, deploying satellites, meeting our commitments to the customers. And I think in this short period of time for a vehicle this complicated, that's amazing. You have to really remember that this press conference is coming from space in the most complicated machine in the world, and here we all have been down here for however many minutes. It runs itself. We're really have made great strides, I think, and I think it's a great future for America and space.
Okay, I have one question for each of you to kind of close this out. Are you anxious to come home on Monday, or would you all rather stay up a little while?
My vote is to stay.
My vote is to stay.
Mine certainly would be to stay.
I'd like to stay.
I want to stay as long as the food holds out.
Okay, thank you very much.
Thank you. We enjoyed it.
And Challenger, this is Houston. You're back with a Moker now.
Roger that. Houston, Challenger, we've got to come reconfigure to our normal configuration now. How do you rate?
Loud and clear, Richard. How me?
I'm clear, Mary. Well, and Houston CDR, I kind of lost track of time. How much time do we have left in this AOS?
We'll be on Tidris for another 22 minutes, and then we have a few more minutes after that when we switch to Botswana.
Okay, thanks a lot.
Welcome.
This is Mission Control Houston at 4 days, 1 hour, 54 minutes mission elapsed time. We still have communication with the Challenger through the tracking data relay satellite and should have that for almost 20 more minutes. Now that the press conference is completed, crew is scheduled to deactivate the television equipment and have their midday meal, after which they will begin working with the payload flight test article and the remote manipulator system once again, picking up the shopping list items that the engineers on the ground would like them to go after with the PFTA.
Houston, Challenger.
Challenger, this is Houston. Go ahead.
Roger, Mary. We got time now. We got time if you do to copy that Telglo information.
Roger, Dan. Jeff's right here, and we'll turn it over to him.
Can't. Challenger Houston, how do you read?
Roger, Jeff, got you loud and clear.
Okay, Dan. We saw those TV pictures, and they were pretty spectacular. What it's telling us is that this is much brighter than we had anticipated. You are the only crew that's been able to see this visually. There's been some speculation that you're dark adapted because of your night launch, but I'm not really sure what goes on there. At any rate, We are anticipating that on the tail glow experiment, the pictures of the jet firings are very likely going to be overexposed. You are taking those pictures at 2 seconds at f/28. What we would suggest is, in addition to doing that, that when you repeat the jet firings, that you stop down the camera, take it at 1 second, and stop it down all the way in order to reduce the amount of light that's coming in. That's the first thing that we would like. Be sure to document the exposures that you make so that we can reproduce afterwards what you've done. The second thing that we would like is to try to get a sequential shot of the glow after the jet firing. You reported it lasts for 5 to 10 seconds, and we believe that by using the motor drive in continuous mode, you can snap a bunch of pictures of, say, 1 second exposures, and that will give us an idea of the decay curve. The third thing is that any pictures or comments that you can get when you're in the EOIM attitude, to correlate what other parts of the orbiter are glowing when you see the OMS pod light up will be very helpful for future experiments. For instance, when the OMS pods light up, can you see the RMS glow? Can you see the EOIM glow? The important thing is to document all the exposures that you take and to try to give us a bracketing of exposures, since we're clearly getting more light than we had originally anticipated. And any other things that you can think of, we would certainly appreciate.
Roger, Jeff, and we'll be sure and do the best we can. I would like to. I did notice last night a couple of things, preliminary observations that I made last night about it, and that is that the glow never completely goes away when you are dark adapted. We had all the lights off in the cockpit, and we were in the EOIM attitude, and I could see the glow on the wings and on the OMS pod and on the tail. I could not, however, and I wondered about that and still do, I could not see any glow from anywhere in the payload bay when I tried that.
You're probably in the best position of anybody to determine what the interesting things are that you can observe, and that's just the sort of information which experimenters are going to need in the future.
And my one. Jeff, I do have a procedural question, I guess, in using the intensifier. My plan is, that we really had a problem the other day and didn't get much on that first try because we took the whole, a good half of the no moon pass with the intensifier on, just getting the thing aimed because of the problems we had. I'm going to try and overcome that. But is there a problem if we leave the intensifier on during the moon phase?
I don't believe that will do any harm to the intensifier. We've had it on in the moonlight on the ground before, and it didn't show any ill effects.
Okay, well, that'll make our job a little bit easier trying to worry about the moon. What we'll do is just turn it on after the sun goes down. We're in night, and then just run the whole night pass, and probably do a couple of those tonight if we got enough film and can get set up.
And one more thing on procedure. We're being told that to take 1 second exposures when you're trying to get an idea of the decay curve, that you should stay on single exposures and just click them one right after the other.
Challenger, this is Houston with you through Botswana for 6 minutes, and I got a couple flight notes to pass up to you before I turn it back over to Jeff.
Sorry, Mary, everybody's downstairs trying to get a bite to eat. Say again?
Okay, Guy, I got a couple flight notes that I got to pass up to you before the end of this pass.
Okay, stand by this moment, Mary.
Okay, Guy, standing by.
Go ahead, Mary.
On your TVO3 PFTA ops, which is the setup for TVO3 is for day 40250. We'd like you to mount an aux light on or near the camera for any night pass use, and it'll help the TV scenes a lot.
Understand aux light near camera for TVO3 PFTA operation.
Roger that for any night pass. And one more on PDRS procedures.
Okay, go ahead.
On the exterior survey procedures on pages 5-15 and 5-26.
Okay, go ahead.
You're to delete all procedures and caution boxes to inhibit the UHF transmit while in the single mode. And the reason we can do that now is the EMC testing has indicated that the adverse EMC effects caused by the lower UHF antenna is not a problem as we thought it might be. So we got a little more leeway there.
Roger, you're going to have to repeat that, Mary. We're having problems picking you up because there's an echo, and which is coming in about a half second after you're talking, and it's difficult to understand what you're saying. Understand you're talking about the exterior survey on the RMS, page 515 to 526, and you want us to...
It was 515 and 526, Guy.
Mary, you want us to delete taking the UHF off, is that right?
Yeah, you don't have to inhibit your UHF transmit at all while you're in the single mode because the EMC testing has showed us that it's not a problem anymore.
Yeah, whatever Inco just did, it stopped the echo.
Okay, we copy that, and if you do tell us there's an echo, he can work on it.
Yeah, I have two more questions, PFTA-wise, Mary. One is, in the summary you sent up, you had an item in there that said DTO repeats or something if required. Do we need to do that? And also, those surveys ask us to go to plus ZLV, and we want to know if that's going to be okay to do too.
Repeat the second, Dale.
The surveys, since they're on the bottom of the vehicle, have you go to plus ZLV to get the bottom of the vehicle towards the Earth shine, and we want to know if you want us to make that maneuver, or just look at the bottom with the spotlight on the RMS as required.
Roger, Dale, just a second, we'll check on that. Dale, on your question about attitudes, when you're doing the exterior surveys, you can delete any attitudes that are called out specifically and just remain in minus ZLV nose forward. And you can go ahead and use an auto DAP because it's an unloaded arm.
Okay, understand. So we'll do the surveys just using the lights on the end of the arm then.
Roger that. And also, Dale, on your DTO question, there are no DTO repeats required. And we're 18 seconds LOS. We'll talk to you again through Guam at 2+41.
Okay, through Guam at 2+41 and no repeats. Thanks a lot.
Mission Control Houston, 4 days, 2 hours, 17 minutes, mission elapsed time. Challenger out of range of the Botswana station. We'll be picking up in 24 minutes through the Guam station. Have a rather long loss of signal period here at the end of orbit number 66. This is Mission Control.
Minus ZLV nose forward, and you can go ahead and use an auto DAP because it's an unloaded arm.
Okay, understand. So we'll do the surveys just using the lights on the end of the arm then.
Roger that. And also, Dale, on your DTO question, there are no DTO repeats required, and we're 18 seconds LOS. We'll talk to you again through Guam at 2+41.
Okay, through Guam at 2+41 and no repeat. Thanks a lot.
Mission Control Houston, 4 days, 2 hours, 17 minutes, mission elapsed time. Challenger out of range of the Botswana station. We'll be picking up in 24 minutes through the Guam station. Have a rather long loss of signal period here at the end of orbit number 66. This is Mission Control. This is Mission Control Houston at 4 days, 2 hours, 33 minutes mission elapsed time. We intend to cancel the change of shift press conference for the off-going flight director Randy Stone. Having made a survey and found little interest at this time, and we have just completed a press conference on orbit with the crew from the spacecraft. So we are canceling the change of shift press conference that would have been held at approximately 5 a.m. this morning. This is Mission Control Houston. This is Mission Control Houston at 4 days, 2 hours, 41 minutes mission elapsed time. Just a reminder that we have canceled the change of shift press conference with the off-going flight director Randy Stone. And we are standing by for acquisition of signal in about 30 seconds through the Guam tracking station. This is Mission Control.
Challenger, this is Houston with you through Guam for 7 minutes. Challenger, this is Houston with you through Guam for 6 minutes.
Hi, Houston. Challenger's here. And we're just starting to get the setup underway for the PDRS work.
Okay, Dale, we're standing by. Challenger, this is Houston. We're 16 seconds LOS. We'll talk to you again through TDRS at 2:57.
Goodbye.
Bye-bye.
Mission Control Houston, loss of signal through Guam. We'll be communicating again with the crew of the Challenger when we pick up the tracking data relay satellite in about 9 minutes. This is Mission Control Houston.
This is Shuttle Control, 4 days, 2 hours, 56 minutes mission elapsed time. Hawaii has acquisition of signal with the Challenger, and we'll be locking on to TDRS in about a minute and a half.
Houston, Challenger, read you loud and clear, Hemi.
You're loud and clear too, Richard.
Okay, we're on page 9-2, just setting up for the direct drive unberth.
Copy that.
And we're getting television from Challenger.
And Houston, City, all right, a couple of 3 questions that I'd like to pass on to you, and when it's convenient, you could answer them. One is, does Prop still think that the jet was a fuel leak? Second, how we're doing on the RCS red line and our RCS consumption? And finally, on the TV04 this evening for the Med TV, I noticed that was scheduled for a Hawaii pass. Are we able to use are we limited to the Hawaii pass? And if so, what is the time? Or the corollary is, do you plan to use TDRS and not worry about if we run over a little bit? And no hurry on the answers, because we're keeping on working here.
Okay, Richard, we'll get answers for you.
Thanks a lot, appreciate it.
Challenger, this is Houston. The prop still does think that that's a very small fuel leak that's caused the deselective L3D. And also your RCS red line is 37 extension days, so that's quite a lot there. And we're going to leave the TVO4 question that you had for the next shift, Orbit 2.
We got the first two, but not the last comment, Mary. Say again.
Your question on TVO4 will turn over to the Orbit 2 team, and they'll talk about it and give you an answer later.
Okay, and we have enough food for about 30 days, so we'll see you October 1st.
Roger that. I understand. Dale wants to come back before he starves. Challenger, this is Houston. We're 50 seconds LOS out of Hawaii before we turn over to Tidris, but we'd just like to say bye. We're looking forward to seeing you. I'm afraid that we're going to make the assumption you can't extend for 37 days. Next Orbit 2 shift is going to be handled by the entry team, and so Randy and the rest of the guys on Orbit 1, and Jeff and I would really like to say it's been fun working with you.
We sure had a good time too, Mary. Thanks a lot. We'll see you down on the ground.
See you there.
Thanks a million, Mary. Y'all did a super job. Appreciate it.
Thanks.
This is Shuttle Control. Hawaii has loss of signal. Here in the Mission Control Center, a handover has taken place. The Orbit 2 team has come on duty with Flight Director Harold Drawn. Capcoms are John Blaha and Bill Fisher.
Challenger, Houston, the Crystal team's with you with Tidris.
Hi, John. How's it going?
Going real good. You guys sure did a good job during the conference.
It was fun. We enjoyed it. Comm through Tidris was great, and we're glad the picture was okay, too.
Roger that, Dale.
And Richard's doing the grapple today. He's has about 10 inches to go coming on in.
Roger, we're watching.
And John, we're giving camera D a try again just to see what's going on. I'm sorry, the elbow camera, and there is definitely something loose inside the lens. It's a metal circular ring. We can see notches in it floating around inside there, so it's definitely come apart.
Roger, we copy that, Dale.
Houston, Studio Dale's out of the latches on the direct drive on berth.
Roger, Richard, and we're watching it with a very clear picture.
Boy, when you're dark adapted, the sunrise is piercing.
Roger that.
This is Shuttle Control, 4 days, 3 hours, 25 minutes mission elapsed time. Challenger is into daylight now over South America on orbit number 67. Crew conducting retests with the RMS and PFTA, continuing to get television through Tidris of this activity. At last report, Spacecraft Commander Dick Truly was at the controls of the RMS.
Challenger, Houston, be advised we're going into a scan limit. We may lose TDRS. If we do, we'll see you at Botswana at 3+44.
Okay, John. See you there. As you can see, we're unberthed, and Dale is getting ready to do the direct drop berth.
Roger that.
This is Shuttle Control, Challenger crossing the African coast now. Approaching the limits of TDRS coverage, about a minute and a half to LOS TDRS. This is Shuttle Control, 4 days, 3 hours, 49 minutes mission elapsed time. We've had LOS TDRS. Challenger is still in acquisition, UHF acquisition at Botswana for another minute and a half.
Challenger, Houston, we're going LOS, Botswana in 25 seconds. See you at Indian Ocean for a short pass in 5 minutes.
Things are going slow but sure.
Roger, and if we don't get you to Indian Ocean, see you at Guam at 4+17.
Okay.
This is Shuttle Control. Challenger is out of range at Botswana. We really don't expect to pick them up at the Indian Ocean Station. A very low elevation pass on this orbit. Duration of that pass would be 22 seconds, so more than likely the next tracking station to see Challenger will be Guam in about 25 minutes. We had television reception through TDRS virtually full time from Hawaii to Africa on this orbit, number 67. As the crew utilized the remote manipulator system with the PFTA. The grapple was done by Spacecraft Commander Dick Truly, and then Mission Specialist Dale Gardner took over the controls of the RMS. Earlier, Gardner confirmed that they could see a loose metal ring in the lens of the elbow camera. He believes that the lens has come apart. It still provides a picture, but it is somewhat obscured. And in a response to a question from Truly as to the status of the reaction control system propellant, crew was informed that they have enough RCS propellant for 37 extra days, so their surplus of that consumable is considerable. At 4 days, 3 hours, 54 minutes mission elapsed time, this is Mission Control, Houston. This is Shuttle Control, 4 days, 4 hours, 16 minutes mission elapsed time. Challenger will be within range of the Guam tracking station in about 30 seconds.
Challenger, Houston's with you at Guam for 4 minutes.
Roger, Houston, land clear, and Dale is In between the trunnions, still going down, but still has a few inches to go. Very slow.
Understand, Richard.
And John, the thing that we are finding is that there's a lot of very low damped or almost undamped oscillations in Y. So after a couple of inputs, we just have to wait for them to slowly damp out so that we can start again. They go almost from trunnion to trunnion. And these are with very slow inputs on Dale's part.
Roger, we copy, Richard. Thanks.
Houston, MS3.
Roger, go ahead, Dr. Bell.
I tell Biomed this is stuff on OBS.
Roger. Bill, can you repeat, please?
Roger, John, he said there was some OBS data coming down.
Understand. Challenger, Houston, we're going LOS here in 20 seconds. We'll see you at Hawaii in 8 minutes.
Okay, John, see you there.
This is Shuttle Control. Guam has loss of signal. Hawaii is next in about 6.5 minutes. At 4 days, 4 hours, 23 minutes. Mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control. 4 days, 4 hours,
Challenger,
30 minutes.
Houston's with you at Hawaii for 6.5 minutes.
Challenger about a minute and a half away from TDRS AOS.
Or actually, when we took the brakes off after 3 or 4 seconds, a couple of them went barber pole again, and we're fiddless.
Roger. In Challenger, Houston, we need to warm up the MADS. If somebody back by A7L could take the strain gauge and put it to on, please.
Roger, John. The MAD strain gauge is on.
Roger, and if it was already in that position, Richard, if you could cycle it, please. We're showing it not in that position.
Negative, it was in PCM enable.
Okay, thanks a lot.
Houston, CDR. Each time that Dale gets 4 grays, when he takes the brakes off, when he puts the brakes on, yeah. Each time that Dale takes the brakes off to go to test mode, one of the latches pops out. We can keep the 4 grays with the brakes on, and we'd suggest doing what we did yesterday, and that is with 4 grays and a brakes on, go in latch.
Roger, we concur, Richard.
Okay, that'll save us a lot of time. I don't know how long this would take. Okay, Houston, we latched the keel latch, and about a second before the keel latch talkback went gray, we lost the ready to latch on number 3. 1, 2, and 4 ready to latch are still gray.
Roger, we copy, Richard.
And Houston, do you concur we should proceed or back out?
Stand by, Richard. Gray auto.
Okay, no problem.
Roger, Richard, we recommend you drive 1 and 4.
Okay, drive 1 and 4 and then watch and see what 2 and 3 do?
That's affirmative, Dale.
Okay, here we go. That was a good call when 1 and 4 started tightening down, 3 came back in. We have 5 grays right now.
Roger, that was RMU, Dale.
Go to test mode now as a limp the arm.
Okay, Houston, Dale is ungrappled, and it looked like there were barely any loads at all on it. We recorded it on the wrist camera, and it came straight out.
Roger that, Richard. Thanks.
And Houston, we're going to go back to ZLP.
Roger that.
And Houston Challenger, you still with us?
Roger, still with you, Dale.
Okay, John, we've started the unloaded auto sequence. I don't know if you guys timed the direct berthing. I think it was something around an hour. I don't think I wrote down the start time, but it was the best part of an hour.
Roger, Dale, and we'll confirm that in the transcript you called out when you were starting the berth maneuver.
Okay, and as Richard mentioned, the main problem, of course, were oscillations, just sitting there waiting for them to cancel out, so we could tell what our attitudes and XYZs were. The other part was, of course, without the elbow camera, we had no way of really telling X, and we had to use some tricks and fish around and try to find the guides. It took a little while. And we did not use any digitals, by the way. It was just cameras B and C and what we could see with our eyes.
Roger, Dale, we copy, and we show 1 hour and 10 minutes, and understand your comments.
Okay, and it felt like it was all of that.
This is Shuttle Control, Challenger coming into sunrise.
And Challenger, Houston, we are receiving a beautiful picture of your sunrise down here. Thanks a lot.
Yeah, we see you watching that.
I'll bet you do. This teeters is really a neat thing.
Bet you nickel your TV view is not as pretty as our window view, John.
Roger, Richard, but it's a lot better than it was before we had the teeters.
This is Shuttle Control, 4 days, 4 hours, 57 minutes mission elapsed time. Challenger crossing the west coast of South America now. On orbit 68.
Challenger, Houston's with you at Botswana for 5 minutes, and I have an overall plan here for you, Richard, when you're ready to listen.
Roger, let me, okay, go ahead.
Okay, Richard, the upcoming Hawaii TV pass will be on schedule. The basic plan will be to TV through Hawaii, and during the pass, about 2 to 3 minutes in the pass, we will hand over to Teeters. Total TV time available will be about 27 minutes. We would like you to continue your RMS testing in the order you have on your message, and at 5+30, we would like you to start berthing and powering down. If some activities don't get completed, that's okay with us. What we're trying to do here is protect about 20 minutes for you to get ready for Dr. Bill's TV show. If you have any other changes to that, we would go along with your suggestions.
Roger, John, I think that's fine with us. We've completed the unloaded auto sequence, and we've gone ahead and we are in the midst. As a matter of fact, we've almost completed exterior survey Juliet, which I think you'll enjoy later on if we get a chance to downlink it to you. since it's about 5:20 now, I don't know whether we, as a matter of fact, I don't think we'll have time to do another survey. So we'll either have to miss out on surveys Bravo and Charlie, or reschedule it tomorrow maybe, or whatever you'd like to do.
We understand, Richard, and that's fine with us to go ahead and go ahead and berth the arm.
Okay, and sometime this evening, you might make plans to, if you'd like to look at this survey. It really is a very capable look at the bottom.
Roger, we would like to do that and will.
Okay, super. We'll work till 5:30 and go ahead and berth, and then be ready for the Hawaii pass. What time is Hawaii AOS?
Yes, sir. Hawaii is 6+04.
Super plan, John. Thanks a lot. Appreciate you updating us.
Yes, sir. And Challenger, Houston, we're going to be going LOS in 10 seconds. We'll see you at Indian Ocean in 2 minutes.
Roger, John, and we're zoomed in the on the states that says United States underneath the radiator. We're at the bottom of page 5-28, backing out for the book.
Yes, sir.
This is shuttle control at 4 days, 5 hours, 26 minutes mission elapsed time. The Indian Ocean Station will pick Challenger up in about 45 seconds. Crew in the process now of securing the RMS operations and preparing for a biomedical TV pass scheduled to begin at Hawaii.
Challenger, Houston's with you at Indian Ocean for 6.5 minutes.
Roger, Houston, and we're in the RMS power down procedure now.
Roger that. Challenger, Houston, if you have a second, if you could give us any comments on whether you are experiencing any of the hesitations in driving the elbow in the single mode that you experienced when you were loaded.
As a matter of fact, absolutely not. It's smooth as silk.
Roger, I understand. And Challenger, Houston, I have a flight note for you if somebody's ready to copy, reference the WMS.
Okay, man. Roger, John, go ahead.
Okay, Richard, basically what we have here is a procedure to try and see if we can't isolate that slight leak a little bit. And to do that, we would like you to first place the foot platform in the lowest position. Second, cut a 3-inch square from a plastic cover off of any FDF book. Third, using gray tape, seal the cover over the WCS vent screen opening, and that's the opening that's behind the outboard foot platform on the upper right side of the WCS front face.
Okay, rather than write it down, let me go look at it, make sure I know what you're talking about. Hang on.
Roger.
Okay, yes, there's a little circular screen on the outboard side of the foot restraint. I understand.
Okay. Fourth, verify that the WCS vacuum valve is open. and notify us when that procedure is complete. If this works, we'll give you another procedure to work with it. If it doesn't, we'll go back to the procedure you have been using today. And don't let this interfere with your TV pass coming up. We'll see you at Hawaii at 6+04.
Super, John. We'll see you in Hawaii.
Roger that.
This is Shuttle Control. The Indian Ocean Station has loss of signal with Challenger. Next acquisition, Hawaii in 29.5 minutes. At 4 days, 5 hours, 34 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control, 4 days, 6 hours, 3 minutes mission elapsed time. Standing by for acquisition at Hawaii with handover to TDRS about 2 minutes later. We expect TB during this pass.
Challenger, Houston with you at Hawaii, and we have 2 questions here before we get started with the TV. First, do you have the WMS configuration established?
We have not done the taping that you asked as of now, John.
Okay, that's fine, Richard. Before you do that procedure, be aware of a caution. Do not operate the WCS in any mode with the plastic cover in place.
Okay, understand.
And Richard, you can use it by removing the cover and then performing the normal WCS ops and then replacing the cover again.
Roger, understand. We'll tie a red string between the cover and the operating equipment.
Roger, red string. And Richard, just another note for you. Your cabin pressure is close to a caution warning limit. If it goes off, you can either live with the alarm or you can go ahead and reset the caution warning limit as you did yesterday.
Okay, how soon would you expect that it might trigger? Mightn't we lower to 10th here so we don't have to put up with it in the next few minutes?
Roger, we're working on an answer for you, Richard.
And Houston CDR, if we didn't get a chance to talk with Inco, but we'll control the camera selections, but we'll leave the panel switch in command.
Roger, we understand and concur.
Okay.
Roger, Richard, you have we think about a half an hour before that CNW would go off.
Okay, no problem. Roger, no problem.
And Richard, one more thing. We assume that you will be selecting the cameras for downlink.
That's firm.
Roger that. That's okay. And we're ready to go with you.
Okay, super. Tell me when you have a picture in the mid-deck and we'll get started.
Roger, we have an excellent picture of the mid-deck. And we are not receiving Dr. Bill.
I am Dr. Bill Thornton, and I've been put on STS-8 as part of a joint effort between flight operations and flight medicine to look at some of the changes in the human body as it adapts to the weightlessness of space flight. As you're all aware, we have the latest in equipment to fly in space, but we are flying with a body that is designed for 1G. It's rather remarkable that it adapts the way that it does, but adapt it does. However, there are still a few changes that we would like to know about, particularly in the neurological system. We have looked for example, at the cardiovascular system, at some of the other areas. So we're looking at the neurological system primarily on this flight. You may notice a couple of electrodes here on my head. This, I've just finished up doing a study by Miss Wendy Angelo, who is a high school student. She goes to Franklin D. Roosevelt High School, Hyde Park, New York, and she proposed a biofeedback study to see if biofeedback was affected by weightlessness. This was selected and implemented by NASA, and this is one of the items that I have been doing. Now we have a whole series of other studies, and would like to show you just various bits and pieces. As you all know, we always have to be aware of which way is up and down on Earth, but here there is no up or down, and so the nervous system has to adapt to that. Now, in addition to gravity telling us which way up and down, it is always constantly pulling on us. We've developed large legs to get around with. This affects the cardiovascular system. We have to have a fairly large cardiovascular system to support that, and many other aspects of the body.
Challenger, Houston, break.
We have learned to cope, for example, with the changes in the cardiovascular
Challenger,
system. So that
Houston,
when we
break.
return from weightlessness, we no longer have orthostatic hypotension, i.e. the tendency to faint.
Roger, Challenger, we need the encryption select to TR, please.
Copy that. And as part of this, we have, for example, put on a treadmill. And here, Guy Blueford will demonstrate this. In addition to the treadmill, Guy is also wearing some instruments which are standard on Earth but have been modified for our purposes. These I wore on launch, and the first day will wear on re-entry. This small tape recorder, for example, was recording my eye and head motions. On this side, we're able to record blood pressure, heart rate, and Guy has been making pretty good use of this treadmill. By the way, we owe a lot of credit to various sundry people for developing these devices. Mr. Henry Whitmore has certainly done an excellent job on this unit, which has flown most of the flights on STS, and Guy's given it a good workout. So Guy, why don't you go ahead and show us what you've been doing. Now, as I indicated, we could record blood pressure and other items on the recorders for study when we return to 1G, but we have been recording vital signs of particular interest to the neurological system. Now, in addition, musculoskeletal system changing in
And Dr. Bill, we're not reading you.
all of our faces are rather broad and puffy. They're really quite edematous. Part of the fluid goes overboard, and part of it moves upward. Now, in order to study this in further detail, since we felt that it was possible that this shift of fluid to the head was causing trouble, then Dale Gardner is modeling the latest in leg wear that we have up here, and this stocking has some special tapes on it, which, when it's pulled into place, we then simply pull these space. He's probably lost a liter or a liter and a half of fluid, and so our real interest, though, is looking at this as it may affect the head and components of the nervous system in the head. Here, I'd particularly like to thank Dr. Tom Moore and a number of others that have worked on this particular aspect of the project. Now, looking at the nervous system directly, the eyes give us a particularly good insight into the way our balance mechanism works. And any of you around JSC may have seen some of the electrodes and things that we have been using, but by putting electrodes beside the eye, such as we have here on Dan Brandenstein, here we have the electrodes that are picking up eye motion, and in addition we have a small gyro, borrowed from a missile, by the way, that is on his head. So as he makes head motions, we can study the way the eyes move and are also recording head motion here. In addition, just stand still now for a second. We can just float him freely and make movements with him, recording him in completely free motion, such as he undergoes. These records then will give us a record of the function of the nervous system as it controls the eyes, which is a particularly complex part of the system. Now, finally, to the nervous system, we resort to other techniques, and since commanders always have very large brains, we're using Commander Truly to demonstrate this. We are now putting some small electrodes on the scalp, which will pick up the brain waves directly. In addition, we then put signals into the body. It may be either clicks that he listens to in the ear, or in this case, we have visible signals, and then by flashing, in this case, flashing the lights repeatedly and recording these brain waves on a small tape recorder, we can bring them back, run them through, and actually watch these signals as they progress through the brain. Now, if changes are occurring, this will allow us to spot any functional changes. And here, simply have the electrodes here, the little amplifier which goes to ordinary 2-channel recorder, and then we let Dick watch the scene, the simple flashing lights go through the optic nerve up into the brain, and we can literally track these well into the brain itself. Now, there are a number of other items that we have on board, but all of these are aimed at giving us a better understanding of the way weightlessness is affecting the nervous system. And
Roger, Bill, let me say a couple of words too, if I may. As you can see, the addition to Bill Thornton to our crew just a few months before was a significant addition to the objectives of this mission. Most of the equipment that you've seen and most of the work that he has done has been done by himself, and I can assure you on this flight, despite the INSAT deploy and the work on the CFIS and the work that Dale Gardner has done on the RMS and the PFTA, that the hardest working individual on board has been Bill. Most of the equipment is his, and he really deserves credit for a tremendous research program that he's working in space. Now, we're not quite through, however, with the TV show, and over the months we have had to put up with what we've called Bill's Chamber of Horrors. So we have a little measurement program of our own, and if you'll just bear with me, we'll show it to you.
Roger, we're waiting for it, Richard.
Well, Houston, thanks very much for listening, and hope you've enjoyed the show. See you later.
Roger that, Richard. It was a great show. Thanks a lot. Roger, Richard.
Roger, John. Why don't we avoid the cabin pressure C&Ws first? What procedure would you like us to use to pump up the cabin?
Roger, Richard. Go to the orbit ops with your reset, caution, and warning limits.
Okay, we'll do that one real quick, and then we will do the WCS procedure right away.
Roger, and let us know when you are finished with the WCS, Richard.
Okay. Houston, CDR.
This is Houston, go ahead.
Roger, I hate to ask you again for clarification, but on this manual cabin atmosphere, was it the set, I thought you said reset C&W limits was a procedure, and looking at it, is it the set C&W limits procedure that you want?
Stand by a sec.
Okay.
Challenger, Houston.
Go.
Roger. It's the set C&W limit portion, not the reset, on 5-10 that we'd like you to follow.
Okay, maybe that's what John, maybe John said the set, and I thought he said reset. Okay, not to worry. Well, I'll get it. I'm in the middle of it now.
Roger.
Houston, CDR.
Go ahead, Richard.
Fish, I got to give you another net problem to work that's slowing me down on this one. Back on CRT, well, I take it back. Disregard. I was making a keystroke error and thought it was some kind of a fault. Hang on.
Roger. Challenger, Houston, back with you on TDRS.
Roger, Houston. Houston, CDR.
This is Houston. Go ahead, Richard.
Roger, a couple of things. I'm going to jack up the PPO2 limits just so we don't have some C&Ws here as they toggle around the 3.4 limit just for a while. And prior to going to bed, I'll put them back at 3.4. And we're recording some stuff on mid-deck TV that I'm assuming that you're not going to be down.
Challenger, Houston. Richard, the part of your transmission following the words mid-deck TV was lost. Can you repeat? Challenger, Houston. Richard, you were cut out. Can you repeat the last part of your transmission?
Roger, it's just that for the next 15 minutes, downlink TV from the cabin.
Stand by, Richard. We're still having some intermittent TDRS problems. Challenger, Houston. Challenger, Houston.
Houston, Challenger.
Challenger, Houston, how copy? Challenger Houston, back with you on Tidris. How copy?
Loud and clear, Fish.
Roger, Dale. We didn't get to hear the end of Richard's transmission, but if I understood him correctly, he was asking if we were going to need the mid-deck TV camera. We are not for this rev. Also, we copied his transmission about raising the PPO2 limits from 3.4 to 3.6, but it doesn't look like he will need to lower those back to 3.4 at pre-sleep. He can leave them at 3.6 as far as we can tell right now.
Okay, that's great. Now you can disregard about the mid-deck, the question about the mid-deck TV. I do have, if you're operating the TV, we're over Africa at the moment, and camera Charlie is pointing ahead of the bird.
Roger.
Fish, if you have a few minutes, we can give you an RMS summary for the day.
Roger, go ahead, Dale. We're ready to copy.
Okay, we started out with the direct unberth. That went pretty nominally. It was fairly easy. Of course, you know, the guides get wider as you come up, so the fact that we didn't have any way of telling X wasn't really too much of a problem. I don't know how long that took, but it wasn't too bad. We already talked a little bit about the direct berth. Not having the elbow camera was a severe detriment, and what we ended up doing was to get X was keeping in some negative pitch on the PFTA, such that looking at the aft guides with the aft cameras, we knew those trunnions would be getting down to the guides first, and then we just sat there and fished around until we got the aft trunnions into those guides, and then took the pitch out, knowing the front front trunnions would drop in. And of course, we mentioned the oscillations were the main problem. Sometimes we'd have to sit and wait 15, 20, 30 seconds for an input to damp out so we could see what we have and figure out our next move. However, the operation of the arm was excellent throughout all that. Response seemed normal to all inputs. The joints always went the direction I expected them to.
Dale, we're 10 seconds LOS. See you at IOS at 7+01.
This is Shuttle Control at 4 days, 6 hours, 58 minutes mission elapsed time. We've had loss of signal through Tidris. The Indian Ocean Station will lock on to Challenger in about 2 minutes, 45 seconds. We'll stand by for that.
Challenger Houston with you through Indian Ocean UHF for 6 minutes.
Roger, Houston, loud and clear.
Roger, Richard. And when you're ready, I've got a short flight note on your EOIM activation procedures.
Roger, go ahead.
Richard, before I do that, we'd like you to take your encryption switch back to bypass.
Wilco, bypass.
Roger. The current EOIM activation procedures that you have in your checklist call for the heaters to be turned on first, and it appears that's masking some of our data. What we would like you to do for subsequent EOIM activations is to reverse the procedures on page FS5-3 of the, FS3-3 of the Orbit Ops checklist. Specifically, you will first do the grid on, then the UV on, and the last step will be your EOIM heater on. And we would also like you to wait 15 seconds between each switch throwing.
Okay, Fisher, copied that for activating the EOIM. Start at the...
Negative 15 seconds, Dan, and we would like you to do the EOIM activation over AGO on Rev 70. 8 plus 05.
It's over, and it should be, looks like an airtight seal, can't guarantee it.
Roger, Dan, did you happen to notice when you placed the plastic onto that area whether there was any suction that held the plastic on there?
I tell you what, I didn't use any plastic because there's screw heads sticking out, and I figured I wouldn't get a seal, so I just used multiple coverings of gray tape and tried to seal it down good.
Okay, Roger, and again, just a reminder that if you use the WCS, you've got to remove that tape, follow your normal procedures, and then replace it when you're through.
Roger, and I don't know how much suction to expect, but it appeared to, the tape appeared to be drawn in a little bit.
Roger, Dan, we're going to watch it down here and should have an answer for you shortly.
Thank you.
Challenger Houston, we're 1 minute LOS. We'll see you at Hawaii at 7 plus 39.
Roger, Houston, and Fish, did you copy Dale's comment about the availability of the orbiter inspection yet on the videotape?
Roger, we did, Richard. We'd like to have you place that Juliet survey on Rev 70 so we can have a chance to look at it down here.
Anytime.
Roger, it'll be just after Hawaii.
This is Shuttle Control. Indian Ocean Station has loss of signal with Challenger. Next acquisition is Hawaii in 29.5 minutes. At 4 days, 7 hours, 9 minutes mission elapsed time. This is Shuttle Control, Houston. This is Shuttle Control at 4 days, 7 hours, 38 minutes mission elapsed time. We're standing by for acquisition through Hawaii.
Challenger Houston with you through Hawaii for 3 minutes.
Roger, Houston, loud and clear. How's?
Got you loud and clear.
And Houston, we're in the roll Star Trek line. There are 3 stars in the table that GNC can look at. We've started a fuel cell purge. And going to try to, Dan is taping the AF window so we can do a little night photography this evening.
Roger, we copy and be advised about 5 minutes after Hawaii LOS, we should be ready for your VTR dump and configuration Juliet survey.
Oh, okay. We'll set her up and be ready.
And Fish had a little extra time, so I fired up the HRM again tonight with a start time of 4 days, 7 hours, and 26 minutes.
Roger. Copy, Dan.
And Houston, Challenger, how much supply water would you like dumped tonight?
Dan, we're going to be asking you to dump 30% tonight out of Tank B and Tank Bravo, and we are 45 seconds LOS. We would like you to take your encryption switch to TR, and we will see you on TDRS.
Roger, we missed what you said about the dump. Why don't you tell us when we get on TDRS?
Roger, Richard. It'll be 30 or 30% from Tank Bravo.
Okay, Tank Bravo, 30%. Thank you.
Challenger Houston through TDRS. How copy?
Roger, Houston, loud and clear.
Roger, Richard. Before we get the VTR dump from you, let me give you a little update on the WMS problem. It appears that our attempt at taping did not fix the leak, And what we would like you to do for the remainder of your flight is as follows. We'd like you to remove and discard the tape that Dan put on covering the WMS vent screen. Then we would like you to take the vacuum valve to closed and leave it closed during your sleep period, including any periods of crew use. You should use nominal operating procedures of the WMS otherwise. Tomorrow we'll get back with you. We will probably ask you to open the valve during the crew day, but stand by for our input on that. Over.
System with the vacuum valve closed at night, and we'll remove the tape. You intend to operate the system with the vacuum valve open during the day, but you'd like us to check with you.
Roger, I think we missed the first part of that, Richard, but I think you've got it all there. And Challenger, Houston.
Houston, Challenger, go ahead.
Roger, I have two more pre-sleep flight notes for you when you're ready to copy.
Okay, go ahead.
Roger, for tonight's LIO changeout, the standard CO2 buildup that we've seen occurring in the past is also occurring on your flight. And for tonight's activities, we would like you to change out 2 LIO canisters as follows. We would like you to do the normal changeout, canister 10 into Bravo, that's canister 10 into Bravo, and the additional changeout will be canister 25 into Alpha. And all subsequent changeouts will be per your cue card.
Okay, understand. Tonight only, change out 2 canisters, number 10 into Bravo and number 25 into Alpha.
Good readback, Richard. And the second message deals with your cryo heater reconfig.
Okay, go.
Roger. O2 tank 3, heater Alpha to auto, and H2 tank 3, heater Alpha and Bravo 2 to auto.
Okay, and you want that now?
Richard, now is fine at your convenience.
Houston, Challenger, are you reading me?
Roger, Richard, we did, and now would be fine. It's okay at your convenience.
Okay, I'm right there.
Challenger, Houston, just be advised we're going to stand by for the VTR dump. We're going to go into some KU band blockage, and we'll let you know as soon as we're ready.
Roger, understand. Your WC, I'm assuming that is primarily...
Challenger, Houston, if you copy, you're broken, Richard. It'll probably be a few minutes before we got you back on Tidris. Challenger, Houston, how copy?
Run clear, House. Houston, Challenger, how do you read?
We hear you, Richard. Stand by. And Challenger, Houston, we have a correction to the LIO canister message. It will be normal changeout, canister 1 into Alpha, and the additional changeout will be canister 2-5 into Bravo.
Okay, the change is 1-1 instead of 1-0, correct?
Roger, plus canister 2-5 goes into Bravo instead of into Alpha.
Okay, let me find the piece of paper again. Okay, Fish, let me try it again. 1-1 into Alpha and 2-5 into Bravo.
Roger, good readback, Richard. And we're having a little trouble with the KU band antenna. We may not be able to get that VTR dump, but if we're able to, we'll give you a call.
Roger, understand, and isn't, you know, it's no big thing. I just thought...
Roger.
Houston, Challenger.
Go ahead, Dan. This is Houston.
Okay, just letting you know that you wanted to watch starting up...
Daniel, you were broken. Go ahead. Challenger, Houston.
Go ahead.
Roger, Dan. Your last transmission was broken.
Okay, I just said I was firing up to EOIM.
Roger, Dan. We're ready when you are.
Plus 05.
Roger, Dan. We're ready. Challenger, Houston.
Roger, go ahead.
Roger, Richard, you can go ahead and close the vacuum vent valve on the WMS now. We'd like to stop the leak if we can.
Okay. And Houston, CDR, did you copy my question about the vacuum vent valve?
Negative, Richard.
Roger, I wanted Econ just to remind Dan and me it's primarily for odor control. Is that correct?
Stand by, Richard. Challenger, Houston, that's affirmative, Richard.
We didn't have any odor problems at all, and I'm assuming, and I'm hoping that when we get up in the morning we can reopen it just to prevent any.
Roger, Richard. We hope to be able to give you the go to do that. Challenger, Houston.
Houston, Challenger, go ahead. Houston, Challenger, how do you read?
Challenger, Houston, read you loud and clear, Richard. Just wanted to clarify something relating to your last question. The vacuum vent valve is related to odor, but as you probably know, the reason we're closing is that it's downstream of the gate valve, and we think the leak is in the O-ring seal of the gate valve.
Roger, I understand. Yes, I understand that. I was just wanted to make sure that we understood the consequences of having to fly with it closed.
Roger, we copy.
And no problem either. We're doing the right thing. I just wanted to understand it.
Roger. Challenger, Houston.
Go ahead, Fish.
Roger, Dale. We're about a minute LOS, Tidris. We will see you again, Guam, at 9+01, and we would like you to take your encryption switch back to bypass.
Okay, back to bypass and see you at Guam 901.
Roger.
That's shuttle control. We've had LOS Tidris.
Challenger, Houston.
We've had loss of signal with Tidris. Next acquisition through Guam in 27 and a half minutes. At 4 days, 8 hours, 33 minutes mission elapsed time. This is shuttle control, Houston. This is shuttle control at 4 days, 9 hours, 0 minutes. Standing by for acquisition through Guam.
Challenger Houston, AOS Guam for 3 minutes.
Roger, Houston, loud and clear, and we were, sorry for the delay, Dan and I are in the aft in the dark taking some glow photography.
Roger, Richard, if it's convenient, we'd like you to give us the position of your encryption switch.
It's in bypass?
Okay, Roger, we're showing it encrypted down here. We wonder if you could give it a cycle and then put it back to bypass.
Okay, how about that?
And Challenger Houston, that cleared it down here.
Okay, I'm not sure what's going on with that switch, Fish, but it was in bypass.
Roger, that's number 2 for that switch. We're working on it down here.
Roger, okay. Fish, are you ready for the DSO report for the day?
Yeah, Bill, give us about 30 seconds and then we'll be ready for your report. And Challenger Houston, briefly, during the last TDRS pass, we saw a load on AC-1, single phase, and we haven't seen it on past flights. Have you folks been doing anything that might explain that?
Well, let's see. They've been using the MSs are downstairs using the movie light. I don't know what it's plugging into.
Roger, we'll check into it.
Stand by. Okay, it's plugged into MO52 Juliet. Roger, it's plugged into MO52 Juliet, whatever power that is.
Roger, we copy. And we're ready for Bill's report. We're only a minute from LOS, though. It might be better if we waited until we got him back on TDRS.
Okay, well, why don't we do that? Okay.
Roger, Richard. And just to let you know, your state vectors go for the next PLS on Rev 81. And your TIG would be 5 days, 0 hours, 36 minutes.
I understand.
And Challenger Houston, we're going to be LOS 5 seconds, TDRS in 11 minutes, and we'll look forward to hearing from you, Bill.
Okay, see you there.
This is Shuttle Control. Challenger's moved out of range at Guam. TDRS will lock up with Challenger in about just over 10 minutes. At 4 days, 9 hours, 6 minutes mission elapsed time. This is Shuttle Control, Houston.
Challenger Houston through TDRS, how copy? Challenger Houston through TDRS, how copy?
Houston, we have you lost.
Roger, you're a bit broken, but I think I heard Dan.
That's perfect.
Roger, Dan. If you folks are still willing, in a few minutes, we will be able to receive that Survey Juliet VTR dump. If you'd rather wait, that's up to you. We're also ready for Dr. Bill's commentary anytime he's ready.
Okay, we'll take care of both of those. First, Bill will tell you his stuff, and then Dale will show you the tape.
Roger, and we've got to give you a go. We're not quite ready for the VTR, so wait for our call, and we're ready for Bill.
Okay, Fish, here comes Bill. Yeah, Fish, the contact lens DSO was done this morning. Along with ocular tonometry, you can tell Dr. Poole that that worked quite well. The fluid sampling, continuous fluid sampling has been continued. Got a couple of leg volumes. Done 3 audio evoked potentials. We've done 3 regular EOGs. A couple of variations. Checked out the
Challenger Houston, Bill, you're fading out. Give it another try.
And did Wendy's biofeedback. Did some additional biological sampling. And looked at our friendly animals. Went over them again. In just a minute, and I'll give you some times on the OBS data that came down. Stand by for that.
Roger, Bill, and you were cut out between the information you gave us on 3 EOGs and the biofeedback, if you could fill that in for us.
Okay. Okay, between the EOGs, as I said, we had 3 regular EOGs, had a couple with variations. Checked out and did a couple of people on the rotator, and that's the wrong word for it. Oscillator would be a more correct word. Did additional work with the gyro, and then did the Wendy's biofeedback. And I'll get you some times on the OBS data that came down. Stand by.
Roger, standing by, Bill.
Okay, the first was an EOG, which was from day 4, hour 04 and 10 minutes to hour 04, 20 minutes. Second EOG was day 4, hour 4. Day 4, 05 hours, 07 minutes. Again, I don't have the ending time on that. And let me get you another time here.
Challenger Houston, Bill, we missed
Okay, Fish, tell them beginning at 03 days, 2 hours, 16 minutes. There was a series of runs. They won't be familiar with the data. And the end time on that that ran approximately 30 minutes. And then it continued on a second run, which ended at 3 days, 23 hours, and 1 minute.
Roger, Bill, we did copy that, but we missed the times for number 2 and 3. Could you repeat?
You're coming in weak, Fish. Say it again.
Roger, could you repeat the start times for numbers 2 and 3? You were cut out.
Wilco. Okay,
Okay, number 2, the start time was 4 days, 04 hours, 30 minutes. I'm sorry I don't have an end time for that one. And for number 3 was 4 days, 5 hours and 7 minutes, and that is an ending time. That's an ending time, and they will have to go back forward from that. That's 040507.
Roger, Bill. We copy. Again, it sounds like you continue to amass a tremendous amount of data, and we're all looking forward to having a chance to get a look at it when you get back.
Yeah, it's pretty interesting, Fish. Thank you much. We'll look forward to it.
Roger. And just a quick question for Richard. I wonder if you folks up there know why you got the DAP reconfiguration message prior to Guam AOS.
Roger, Fish, I was going to tell you about that. Stand by. Yeah, Fish, the reason for those was we had to deselect some jets per the glow photography procedure, some vernier jets, and when you deselect them, you get a DAP reconfig message, and then we completed the procedure and reselected them, and we went through it 2 or 3 times, and so that's what it was. We never got out of the EOIM attitude more than 2 or 3 degrees, I think.
Roger, we copy.
And incidentally, we're hoping to do that again the next night pass, so don't be surprised. If you see that, that's what it'll be.
Roger, and we are not yet locked up on KU, so we can't receive your TV yet, but if it doesn't take much longer, we'll call you as soon as we are ready to receive.
Okay, well, we're ready right away.
Roger. Challenger Houston.
Goldfish.
Roger, you folks can go ahead and torque the stars in the table, and if you could, we'd like the star numbers.
Stand by. Roger, Houston, the star numbers are 4, 4, and 11.
Copy 4, 4, and 11, Richard.
Roger that. And you have the other data?
Roger.
Okay.
This is Shuttle Control. The next change of shift briefing is scheduled for 12:30 p.m. Central Daylight Time with Flight Director Harold Drawn in room 135 of the JSC News Center. Next change of shift briefing, 12:30 p.m. Central Daylight Time.
Challenger Houston.
Go ahead.
Roger, Dale, we're ready for the VTR dump.
Okay, here it comes. Got a picture, Fish?
Roger, we do, but it's there. We have a good picture now. We can see the end effector.
Okay, you can see the very tip of the end effector and the Earth and the bottom of the orbiter coming into view. These are the first scenes we saw as we got the arm underneath.
Dale, we've just lost
now
the
what
picture.
happens after this is we put mostly various wrist joints through different rotations to see as much of the bottom of the orbiter as we can with this given shoulder and elbow pitch configuration.
Roger, Dale, we've lost the picture.
Yeah, I'll stop the VTR until you get it back.
Roger, I'd recommend you rewind because the initial part of your picture, we just saw the end effector heading under the orbiter, and then our picture became broken.
Okay, no problem.
Challenger Houston.
Go ahead.
Roger, we'd like to have you initiate a cabin repress now. I've got a few steps for you right this minute, and then a couple more pre-sleep.
Fish, would you say again? We didn't quite understand, but go ahead.
Roger, Richard. I'll tell you, we have a cabin repress for you, but if you could give us the VTR now, we're ready to receive that, and we'll give you the message after the dump.
VTR starting now.
Okay, Roger, Dale, we have a good picture.
Okay, and I won't have to do too much description. You'll be able to see for yourselves. It's a pretty good survey at the bottom of the vehicle. You'll be able to see the wing tips from the bottom, the landing gear doors, and some pretty views. And Richard and Dan are standing by for the instructions on the press while we're watching this.
Roger, I'll go ahead and read those. Now, what we'd like you to do is take the O2 reg inlet system 1 to closed and the 14.7 cabin reg inlet system 1 to open.
Okay, Fish, we got somebody down there in MO10W now. Say them again, please.
Roger, Richard, and we're doing this because we'd like to get your cabin pressure up a little higher prior to pre-sleep. We'd like to have that pressure start a little higher than you would have been starting it with. First on MO10W, O2 reg inlet system 1 closed and 14.7 Raj, and 14.7 cabin reg inlet system 1 open.
Roger, that's done.
Okay, and you will secure this prior to sleep by taking 14.7 cabin reg inlet system 1 to closed and the O2 reg inlet system 1 back to open.
Okay, understand. We will secure the system by reversing what we just did, and that is system 1 cabin reg inlet. Is that correct?
Roger, Richard, that's correct. And for Dale, most of the TV picture that we're getting is good, and we have a superb detail of the tiles and gear door. We can see really a great amount of the bottom of the orbiter.
Houston, Challenger.
Roger, go ahead, Richard. Challenger, Houston. Challenger, Houston, reacquiring TDRS. Richard, we did copy, I believe I copied your last transmission. Challenger, Houston.
Houston, Challenger, go ahead.
Roger, Richard. Your last transmission was correct. The activities you do immediately prior to sleep are to undo the 2 steps that we just called up to you. Challenger, Houston. Challenger, Houston.
Hello.
Hello, Dale. We've had some TDRS problems. If Richard was trying to contact us, we're ready to copy.
Oh, we weren't calling.
Okay, Roger. We just wanted to verify that you understood the pre-sleep activity was just to return the O2 reg inlet and 14.7 cabin reg inlet to their previous positions.
Affirmative, Fish. We copied that and understand. Thank you.
Roger, Dale, and we were able to see most of that film on the Juliet survey, and indeed we saw some spectacular views and tremendous detail. Thank you very much.
You bet. We'll bring the rest of it home with us.
Raj, and if you wouldn't mind keeping it handy, since some of it was broken, we would maybe like to ask you to send it down to us tomorrow.
Okay, I stopped it right in the middle there when I saw the KU signal strength go to 0, so we can pull it out and then just stick it back in at this point when you ask us tomorrow.
Dale, we'd prefer you rewind it because maybe 20-30% of what we got down here was scrambled. So if you could just maybe prepare for a complete playback, we'd appreciate it.
That's easy to do, too. You got it.
This is Shuttle Control, 4 days, 9 hours, 55 minutes mission elapsed time. Challenger over the South Atlantic on the tail end of orbit 71. We'll shortly enter orbit 72. A flight controller shift handover will take place in the Mission Control Center at noon Central Daylight Time. And Flight Director Harold Drawn will be available for change of shift
Dan.
briefing.
We don't have much more for you. We would like to get a resume Spec 60 on CRT-2. And outside of that, you guys have had another outstanding day. There's just can't improve on the kind of work you're doing. Hope you have a good night's rest, and we'll see you in the morning.
Roger, Houston, and how much time is left in this pass?
Roger, Richard. We have about 11 minutes on TDRS.
Okay, I'd like to thank you guys for a super day also. This RMS testing and so forth has been tedious up here, and you've caught us in, I hope, all of our mistakes, and we really appreciate it. I just realized at the end of this day that I had forgotten to say something on the air-to-ground that I had wanted to all day, and that is that this year the space program lost a very dear friend, by the man by the name of Eddie Block, who has spent his life doing three things primarily: training astronauts in physical conditioning, training professional football players, and treating crippled children. And very few people in the country could meet a bit better or a bigger man than Eddie, and we're all sorry to see him go. Thanks very much, and if you have any need to call us for the remainder of this teacher's pass, feel free, Fish.
Roger, Richard, and all you guys have a good night's sleep.
You bet.
This is Shuttle Control. Crew is beginning sleep period. Still about 9.5 minutes left on this TDRS pass, so we'll stand by for any further air ground. We don't expect any, however. The shift handover is at noon Central Daylight Time, and Flight Director Harold Drawn will be available in room 135 for the change of shift briefing at 12:30 p.m. Central Daylight Time. 12:30 p.m. Central Daylight Time for the change of shift briefing.
Challenger, Houston.
Roger, go ahead.
Roger, you may get a cabin CO2 message. Your CO2 is 7.4, so just don't be surprised.
Okay, by golly, there it is. Houston, CDR.
Houston, go ahead, Richard.
Roger, I'm sure y'all are interested in seeing our configuration before we go to bed, so we're going to go ahead and change the LAO cartridges now and configure the ECLS system.
Roger, Richard, we concur. And Challenger, Houston. Challenger, Houston. Challenger, Houston, and the blind message 47 will have your cap summary for tomorrow.
Shuttle Control. TDRS loss of signal on orbit 72. Challenger, a couple of minutes, will enter the night side of that orbit. And the Challenger crew preparing for rest. Here in the Mission Control Center, a handover is underway, and a change of shift briefing will occur at 12:30 p.m. Central Daylight Time. At 4 days, 10 hours, 10 minutes mission elapsed time, this is Shuttle Control, Houston.
This is Mission Control, Houston. At 4 days, 10 hours, 29 minutes, mission elapsed time. Handover has occurred in the Mission Control Center. Flight Director Jay Green and the planning team of flight controllers are now on duty. And off-going flight controller Harold Drawn will be available as scheduled at 12:30 Central Time for his change of shift press conference in Building 2, Room 135 at Johnson Space Center. The sleep period has begun on board Challenger, and we're now about 50 minutes into that sleep period. This is Mission Control, Houston. This is Mission Control, Houston, at mission elapsed time 4 days, 11 hours and 55 minutes. Everything continues to be quiet on board the Challenger. There's 5 hours, 45 minutes remaining in their sleep period. The mission control team, planning team, and the control center is orchestrating a crew activity plan for the next flight day activities, and some videotape is being replayed in the control room to show the flight controllers some of the events which occurred while they were off shift, including the press conference with the national news media representatives, which occurred early this morning. Again, systems on board Challenger continue to function nominally, and downlink telemetry indicates a healthy and sound vehicle. This is Mission Control, Houston. This is Mission Control, Houston. Challenger is on orbit 74 over the heart of South America presently, and there are just under 5 hours remaining in the sleep period, and the crew is passing an apparently uninterrupted evening. No caution and warning alarms have been triggered, and we of course continue to take data as the Challenger flies over ground stations. Data reveals the orbital parameters to be 120 nautical mile apogee, 118.2 perigee, an orbital period of 1 hour, 29 minutes, 4 seconds. And call up some life support information here, and I'll read off what the temperature and humidity levels are on board. Life support temperature on board the vehicle is 80 degrees, and steady humidity 27%. 80 degrees may in fact be a little warmer than it is inside the cabin, since the sensor that records that data is located fairly close to some avionics gear, and it tends to get a little toastier than it is in reality in there. Mission elapsed time is 4 days, 12 hours, 59 minutes. This is Mission Control, Houston. This is Mission Control, Houston, at 4 days, 13 hours, 48 minutes. Mission elapsed time We're in the middle of a rather long loss of signal period presently on orbit number 74. We don't acquire for another 40 minutes still until the Challenger encounters Dakar. Presently the vehicle is just over the northern tip of Australia. 4 hours remaining in the sleep period, and the crew has continued to spend an apparently uninterrupted night's sleep. And the planning team here in the Mission Control Center continues progressing through establishing a crew activity plan for tomorrow's flight activities. This is Mission Control Houston. This is Mission Control Houston. 3 hours remaining in the astronaut's sleep period. We've just had acquisition of signals with Challenger over Dakar, and the flight control team is looking at the downlink telemetry and verifying nominal systems on board the vehicle, and that there have been no caution and warning alarms to interrupt the crew's sleep. This has been a fairly long loss of signal period of just slightly over an hour since the last time we had a look at the vehicle. And it is, of course, always reassuring to note that nothing has happened over the LOS periods. Mission elapsed times presently 4 days, 14 hours, 40 minutes. This is Mission Control Houston. This is Mission Control Houston. Challenger on orbit 76 over the South Pacific presently. The planning team is presently reviewing the execute package and checking it for accuracy and spelling, and making sure that it's suitable for uplink to the vehicle here just before the wake-up period. There's 2 hours remaining in the sleep period for the Challenger astronauts, and the execute package will include activities budgeting the astronauts' time on their final full day in space. And that execute package will, of course, be made available in the newsroom at Johnson Space Center and will be sent to the our sister centers for media access. The astronauts continue an uninterrupted sleep period and begin the next day's activities in approximately 2 hours. At mission elapsed time for 4 days, 15 hours, 30 minutes. This is Mission Control Houston. This Mission Control Houston. Mission elapsed time is 4 days, 16 hours, 17 minutes. About an hour and a half remaining in the crew sleep period. Everything continues to be quiet on board the vehicle, and downlink data affirms that onboard systems are performing nominally. Our intention is to cancel the change of shift briefing scheduled for 9 o'clock with Flight Director Jay Green due to the uneventful night and the fact that there are no changes in status of the flight since the past change of shift briefing. If any news media representatives take exception to this plan and do wish to have a press conference, please notify the Johnson Space Center newsroom at your earliest opportunity. The news center can be contacted at 483-5111. Again, our intention is to cancel the scheduled 9 o'clock change of shift news conference. The mission labs time, 4 days, 16 hours, 19 minutes. This is Mission Control Houston. This is Mission Control Houston at Mission Labs time, 4 days, 17 hours, 8 minutes. There are 30 minutes remaining in the crew sleep period, but we just passed a brief AOS over Arroyo, and the downlink data indicated that all 4 CRTs, all 4 cathode ray tube displays on board Challenger are on and operating, which would suggest that the crew is awake, although there are 30 minutes remaining in the sleep period. We acquire signal again in 23 minutes through the Merritt Island Land Station, and it's doubtful that the flight control team will initiate a contact at that point. Presumably that won't occur until we acquire through Dakar in about 38 minutes from now. At that point, the sleep period will have expired, although it's certainly conceivable that the crew will initiate contact before then. There's no suggestion that any caution and warning alarms have occurred to interrupt the crew's sleep. And Challenger is presently on orbit 77, just having swept across Australia and now in the heart of the South Pacific. Mission labs time, 4 days, 17 hours, 10 minutes. This is Mission Control Houston. As a reminder and advisory, our intention again is to cancel the scheduled 9 o'clock change of shift briefing with Flight Director Jay Green, since the night has been uneventful and there have been no changes in status of the vehicle or flight control since the past change of shift briefing earlier today. We do intend to cancel that change of shift briefing, and if any news media representatives take exception, they should advise the Johnson Space Center Press Center of their desires, and the Press Center may be contacted at Houston telephone number 483-5111. This is Mission Control Houston. This is Mission Control Houston. Mission elapsed time 4 days, 17 hours, 44 minutes. Number of indicators showing that the crew's awake and active. The cathode ray tube displays on board Challenger have been activated. The ECOM has advised that the data shows a fuel cell purge being executed on board. Sleep period has now expired. Likely we will not. Challenger's presently on orbit 77, right across the heart of the North Atlantic Ocean. But we catch just a brief pass through Dakar and Madrid. Likely we will not have communication with the crew at those stations. However, since those are both extremely brief passes and elevation is very low through Dakar, elevation is shuttle passes only 1.5 degrees maximum elevation over the horizon, and through Madrid maximum elevation is 1.6 degrees over the horizon. Accordingly, those are very brief passes, and likely we will not initiate dialogue with the crew until we reach Indian Ocean Station in about 20 minutes from now. And the data downlinked again reaffirms that no caution warning alarms had been triggered during the night, and the crew's sleep period was undisturbed. So with the crew up and around and the new flight day on the horizon. We will stand by for air to ground in about 20 minutes at mission elapsed time. 4 days, 17 hours, 46 minutes. Again, repeating our intention to cancel the change of shift briefing with Flight Director Jay Green. That briefing scheduled for 9 o'clock. Due to the uneventful night and no new items to discuss, we do intend to cancel that briefing and urge news media members to advise the Johnson Space Center newsroom if they take exception to that plan, and to please do so soon. This is Mission Control Houston.
Good morning, Challenger. Good morning, Challenger.
Morning, Houston. Thank you for that thoroughly enlightening cultural experience.
Well, it was a toss-up between that and the Wisconsin fight song, and that one won.
How much water you want dumped this morning?
Okay, Dan, we'd like you to dump tank Bravo to 20%. Take about 35 minutes. And I've got 2 other notes for you when you're ready to copy.
Okay, go ahead.
First of all, perform the manual cabin atmosphere management as you did yesterday. Repress the cabin with nitrogen per the Orbit Ops checklist, page 5-10. And do not perform the repress during WCS use. And on panel R1, the cryo management scheme this morning. Cryo O2 tank 3 heaters alpha to off. Cryo O2 tank 2 heaters Bravo to off. Cryo O2 tank 1 heaters Bravo to off. Cryo H2 tank 3 heaters Alpha and Bravo to off.
Okay, Houston, tank 2, correction, O2 tank 3 heaters are all off. O2 tank 2 Bravo off. O2 tank 1 Bravo off. And H2 tank 3, all the heaters are off.
Roger, and we'll see you next at Indian Ocean at 18 plus 05.
Okay, thank you.
This Mission Control Houston at 4 days, 17 hours, 52 minutes. Commentator clearly guessed wrong about the intentions to wake up the crew. That they did take advantage of the UHF pass over Dakar to uplink that wake-up music, and the wake-up call this morning was, well, I'll just spell it, Tala Sawari, T-A-L-A, second word S-A-W-A-R-I, which is some traditional Indian folk music as performed by renowned sitar player Ravi Shankar. The selection deemed appropriate by the capsule communicators, and as much as the primary mission of STS-8 is the release of the Indian satellite. That wake-up call acknowledged by Challenger pilot Dan Brandenstein. And we'll acquire signal again in 12 minutes through Indian Ocean. Mission elapsed time is 4 days, 17 hours, 53 minutes. And in the absence of any request to the contrary, we now officially declare the 9 o'clock press conference canceled. This is Mission Control Houston.
Challenger Houston with you at Indian Ocean for 6 minutes.
Roger, Houston, loud and clear.
And we've got you loud and clear, and we're standing by.
Okay. Houston CDR, if you get an opportunity, would you fire us up one more copy of message 48, the TAC and nav numbers?
Wilco.
Thanks, Brian. You ought to see the sunrise, Brian. Beautiful.
Well, I bet it is.
This EOIM attitude is like riding in a big tour bus.
Roger that.
These upper windows are looking straight ahead.
Well, that must be spectacular.
In the front, and sitting up in the CDR and the PLT seat, the front windows look like you're going to just slide right out the front, get straight down.
Challenger, Houston, 40 seconds to LOS. We'll see you next at Yarragadee at 18 plus 21.
Okay, see you there.
It's Mission Control Houston at 4 days, 18 hours, 13 minutes. Mission elapsed time. Just lost signal on orbit 77 through Indian Ocean Station. The EOIM attitude that Dick Truly referred to is the evaluation of oxygen interaction with materials. Payload on board, which carries instrumentation to obtain quantitative rates of oxygen interaction with materials used on the orbiter and future advanced payloads. And the orbiter is flying at this 120 nautical mile altitude in order to bang into more oxygen molecules and to further enhance the impact of those molecules. The vehicle's placed in an attitude with its nose down in the payload bay, facing directly into the velocity vector. Accordingly, the crew looking out the forward flight deck windows gets an extraordinary panoramic view of the Earth as it rolls past underneath, and that prompted Dick Truly's remarks. We will acquire signal again in 6 minutes through Yarragadee. At mission elapsed time, 4 days, 18 hours, 15 minutes. This is Mission Control Houston. This Mission Control Houston will have voice in just a few seconds through Yarragadee.
Challenger, Houston, with you at Yarragadee for 6.5 minutes.
Roger, Brown, loud and clear.
Read you the same, Richard, and we're standing by. Challenger, Houston, 30 seconds to LOS. We'll see you at Auroral at 18 plus 30.
Roger, Houston, Steven.
Challenger, Houston, with you at Auroral for 2 minutes.
Roger, Houston, read loud and clear.
Read you the same, and we're standing by. Challenger, Houston, have a word for you on your IMU align.
Roger, go ahead.
Roger, Richard, we see 2 good stars in the table, 44 and 11. If you can torque those in the next 30 minutes, you can do that and cancel your roll align.
Okay, we'll torque the stars in the table right after we cross the continent.
Roger. And Challenger, Houston, we'd like you to go to minus ZLV as scheduled.
Roger, Houston.
Challenger, Houston, 20 seconds to LOS. We'll either see you TDRS at 1844, or if that doesn't work, Mila at 19 plus 05.
Roger, Houston, see you later.
Mission Control Houston, 4 days, 18 hours, 33 minutes mission elapsed time. Astronaut Dick Truly preparing to do the alignment of the inertial measurement units, part of the navigation system on board the shuttle. He was informed by ground controllers that the star trackers have acquired 2 usable stars for the alignment of those measurement units. Crew is just now getting into their day, not yet to the point in the timeline where they have the specific activities laid out for them, but they're in the period of time set aside for them to prepare their breakfast and get ready to face the day. Challenger on orbit number 77, the last quarter of that orbit, just out of range of the Auroral station, passing out over the coast of Australia at this time. We expect to hear from the crew in about 10 minutes if we acquire them through the tracking data relay satellite. Otherwise, it'll be about 30 minutes when we get them over the continental U.S. This is Mission Control, Houston. Mission Control, Houston, we have acquisition through TDRS.
Challenger, Houston, with you, TDRS, for another 49 minutes. Standing by.
Roger, Houston, read you loud and clear.
Roger, read you the same, and we see the dump complete, the torqued platforms, and the fuel cell purge.
Roger, and if you need the numbers on the IMUs, I've got them.
Challenger, Houston, we got all the numbers, thanks. Challenger, Houston, Richard, we got all the IMU numbers. We do not need them. Thanks.
Roger, Houston, copy. Houston, 2 questions. One is, since we're all up and awake, can we reopen the vacuum vent after we repress the cabin? And the second is, with the deletion of the IMU roll Star Trek maneuver, do you want to deactivate the EOIM on time or delay it until just prior to the ZLV maneuver?
Challenger, Houston, your go on the vacuum vent, and we'll get back to you on the EOIM deactivation.
Okay, Houston, thanks.
Challenger, Houston, we'd like you to go to the ZLV attitude on time and deactivate the EOIM just before doing that.
Roger, ZLV on time and deactivate EOIM just prior to that. We'll do it.
Roger.
Houston CDR, I've done the N2 repress and also opened the WCS vacuum vent valve, so if you'd keep an eye on it, we'd sure appreciate it.
Challenger, Houston, we copy.
And Houston CDR, another word, except for the gate valve leak, the system is still working as designed.
Houston copies.
Mission Control, Houston, 4 days, 19 hours, 8 minutes mission elapsed time. Challenger now passing over the southern tip of Florida at the present time on orbit number 78. We still have contact with the Challenger through the tracking data relay satellite.